Great. Well, let's start because we've got a busy schedule for this morning. So good morning and welcome all to the Visa workshop jointly held between Expands and PaNOSC. Just a couple of housekeeping comments. So we encourage you to submit as many questions as you may have. And as you like, at any time during the presentation, please submit these via the Q&A function at the bottom of the screen. There is a chat function also. Please leave that for any technical issues you may have or things that you can't see, can't hear, that kind of stuff. But ideally keep the questions to the Q&A function. Any questions that have been asked by any participants, you have the option to upvote them, therefore giving them more weight and priority and get them to move up the list. We would like to ask you to display your name as follows if possible by having your first name and surname and ideally with your affiliation behind, just so we know where you're from and who you're talking to. And also please note that this webinar is being recorded and we will look to make the video and the presentations available after the event. Just to cover briefly the agenda, I'll only cover it up until our lunch break today. So for those in the UK, lunch will be early at 11:30 for 1 hour, and for our friends on the continent, it'll be at 12:30 for 1 hour. This morning, I will shortly hand over to my colleague Jean-François Perrin with regards to doing the general introduction to PaNOSC and Expands and also giving an overview of Visa, followed by session 1, which is the Visa, a virtual infrastructure for scientific analysis, which will cover a couple of demos, followed by a Q&A session. So I will stop my presentation and hand over to Jean-François, please.
Good morning, everybody. So I'm in charge of giving a small, very small, I will keep it as small as possible, introduction of the two projects. And I will introduce Visa. But after my quick talk, you will get demonstrations, so you will understand how it works and what the benefits you can get from it. So Visa has been developed in 2 EU projects that are running in parallel and are working together. The first one on my slide is PaNOSC, who started in 2018 and will end in November this year. The second one is Expands. We have most of the facilities regarding neutron, most of the neutron or synchrotron facilities, X-ray facilities represented in the 2 projects. We'll see it just after, and this is just a cheat sheet. So this is what I was explaining. We have almost all the facilities, the user facilities in Europe. We have some extra partners like EGI, who is helping us with the compute side mostly, and the integration into the EOSC. We work also very closely with Géant, which is an organization that regroups all the NRENs, so the Network for Education and Research in Europe, that is helping us with the authentication. So it's very large projects, and we have some outcomes. So here you see the people participating in orange, the people participating in PaNOSC, and in blue, the one participating in Expands. We have some success, I would say, some achievements at least. These 2 projects were focused mostly on 2 topics. The FAIR data, so I need to introduce what means FAIR, probably for some of you, and the services for the users. And these services should join EOSC, which is the big European project aiming to provide data and services for the science communities. So one thing is the data policies. The data policies that exist in most of the, and have been published in most of the facilities, have the same form, contain the same process, the same workflow inside. This is because we discuss all together a framework. At the end of 2018, we started. It was published in 2010. So it's some years ago now, and in the 2 projects, we have looked back to this framework to continue to align our policies and adapt our policies to the current situation. So these frameworks have been published, they are available on Zenodo. Another action was the e-learning platform. We now have e-learning platforms full of trainings. And this is also a platform where you can use to organize schools and trainings. This is available under pantraining.eu. Lots of sections on the data management side. So almost all the RI, research infrastructure, or what I call user facilities, have their data catalog that has been published. Some of them contain open data. For some others, the data are still under embargo, but will be open at some point. But all of us have a data catalog now. We have common APIs to access the data. We organize ourselves around DOIs for identifying the data. We have put in place services around DMPs, so data management plans, with the aim to help our users that have to fill DMPs. We can provide a lot of information for the users and have something much simpler for the users, and so forth. So lots of work around data management. In terms of services, we have also worked on the transfer of data, how the users could transfer their data. You will see Globus as a service popping up in a lot of facilities, not all of them for now. We work on the community AI, so the authentication and authorization of the people in the community. We wanted to be ready for joining EOSC, so the EC project, and this is mostly the case, but we will talk about that probably later in the year. And the big one, the one where we are there today all together, is the development and deployment of data analysis services. So the key objectives, the high-level objective for the data analysis services was to keep the scientific articles production by our users as important as today, even facing the complexity, the growing complexity of the experiments, and typically the volume of data sets. It's not rare now that for some of us, we have data sets of 2-3 terabytes. Even for some of us, this is in the order of 100 terabytes. It creates a real problem for the users. I will go into that just after. We would like also to contain the time for the users to publish their work after the experiment. This is linked to the first point. We would like to find solutions to be as fair as possible. So fair means findable, accessible, interoperable, and reusable. What it means in practice for this service is that the processing of data is reproducible. And this is a clear target for us. And we want, this is a bit of selfishness, but we want the computing infrastructure of the user facility as safe as possible for the research activities, and the running cost of this service as low as possible. So typically, we identified from the beginning 2 main possible solutions, either providing Jupyter notebooks, either providing desktop interfaces in a web browser to allow users to remotely process the data. So Visa has been built around these 2 main ideas. We know that Jupyter is probably the future for a lot of us, but not for all of us. Many benefits with the Jupyter notebooks in terms of ability to reproduce the workflow, to document and reproduce the workflow. But we also know that lots of the softwares difficulties to adapt to Jupyter. And in the real life today, scientists also need for some experiment a real desktop interface. This is the way they work since many years, and they will continue to work with that. So in terms of specifications, we wanted to simplify the processing activities for the users, clearly. To have a service which is a remote service and web, where nothing has to be installed on the computers of the users when they are remote. We really would like to target the question of the data transfer and the question also of storage for the processing. When you talk about even a few terabytes, that could be a real problem for the users. We are targeting also the difficulties sometimes to install the software. Get the resource, the computing resources, so simply CPU, GPU, HPC resource, to target this problem for users. And also we wanted the solution that could help the user facility expert to support the users during their processing. So I'll already talk about that. And in terms of cybersecurity, we wanted to isolate these services as much as possible from the production network of the user facilities, the research infrastructure, and to keep it up to date in regard of security patches and all problems that could happen, which is sometimes difficult in the user facilities. So we come up with a solution which is called Visa. This solution provides an access, remote access to the experimental data. They provide software. It provide the computing infrastructure and the solution for the support. This is very, I would say, very easy solution for the users. They can sit in their home lab, and they will have access to a remote desktop as if they were sitting in the cabin or the hutch of the instrument in the user facility. They have also access to Jupyter Notebook environment. In the same way, they can share it. They can work. They can share the screen and allow to work with different people, colleagues. And in terms of machine management, this is relatively simple for the user facility. In the case of ILL, there is also something which is not happening elsewhere for now, is the fact that the instrument control software has been installed in Visa, and it allows to perform remote experiment as if the user was sitting in the cabin. So from a user perspective, there is a very simple workflow. User has to log in. He will be presented with the list of experiments and data where he has access. He will be offered to start a machine. He could customize the machine, choose between a range of CPUs. How many CPUs does he think he needs? Memory, GPU, screen resolution. This is an example on the right of this interface. Then you just click on the button to connect to the machine. I will show in the next slide how we can choose between Jupyter and the remote desktop, but this is the same machine. So the user has a machine for his own need, dedicated to his own need. He can share the interfaces. So the web browser could be shared with colleagues or user facility staff if he needs support. So scientific support or technical support. The results are usually stored alongside the raw data by the user facility. So when he comes back, I can restart the processing or look to the processing with all the information, with all the previous informations. And the machine is deleted after n days. N days could be 2 weeks, for instance, could be 3 weeks. Depends on it depends mostly on the user facility, what they provide. And in case of inactivity, if the machine is not used, usually after a few days, the machine is deleted. But the user can either request an extension, or come back and start up a new machine where we'll find again the same data and the same software. If we go a bit more into the detail, this is what you can see when you request a machine. With the connect button, you can choose either a remote desktop, so this is a Linux interface, or the Jupyter. And you can change from one to the other when you want. In the same way, if he looks to the settings, he will find a menu called members, where he could add some members. And these members will have, when they connect to Visa, we'll have a tab where they can retrieve the machine that have been shared with them. And this is extremely convenient and very, in most cases, this is what we see. So where are we in terms of deployment in the project? It has been initially, Visa has been initially developed by the ILL, so the Institut Louis-Langevin in France, Grenoble, and they roll out the system, the service, early in 2020, just before the COVID crisis hit us. It has been extensively used, and this is a real success for the ILL. The figures you see there, 1,200 of distinct users, is the figures from June 2022. It's a bit higher even now. Nearly a bit more than 8,000 machines that have been created, and more than 70,000 connections. This is really huge. And when you start as an IT person, when you start a service, you quite often have difficulties to reach these numbers. Then with PaNOSC, Visa has been further developed to fit the needs of the different partners. We could have different needs than the ILL. And typically, for some of us, we needed to add HPC resources, so the cluster, Slurm, call it the way you want. We needed to have some GPUs available. This is specific to some software that require GPU. We had tried inside the PaNOSC and Expanse. Sorry, I did forget to mention Expanse there. We have worked on the software provisioning. How could we provide software, up-to-date software for the machines? Currently, the target is to use containers for that, but this is still in development. There is some question which happened about Windows software. Currently, Visa is only providing Linux machine, but some beamlines, some instruments use Windows software. What will be the solution? This is in development. And something that has appeared in PaNOSC is the use of Visa, not only for data processing, so user processing the data he has collected during an experiment, but also for training. And this is very convenient, very easily. You can pop up 50 machines, more than that, depending on your infrastructure, to provide environment for workshop trainings where the people should have hand-on sessions. So currently, we are still in deployment, and this is the case for all the partners. Different stage, but all of us are in contact with some beamlines inside their user facilities to collect the needs and the use to deploy the softwares. And some are just starting to open interfaces. I've put 2 of them there, but probably a bit more, and this is happening very, very quickly. That's all for the introduction. I would like to thank you for your attention, and it's time now for demonstrations.
If you can stop sharing your... Perfect.
Okay, go on. Kat, would you introduce the second session before I talk? Or
Yes, of course I can. So the second session is going to be a virtual infrastructure for scientific analysis overview, which will be chaired by Majid Onsi from Soleil. So we'll have a demonstration by Sylvain from DESI and also an ILL demonstration, followed by a question and answer session. There is already a couple of questions in the Q&A. But we'll come to those in the Q&A session. I know one of the questions has already been answered. Thank you, Fabio. Over to you, Majid.
Yeah, thank you. Thank you very much, Kat, and thank you, Jean-François, for this very clear and concise introduction to the Visa platform. While I think people who are attending the meeting will see what Jean-François described briefly now demonstrated in real life. Now I'll hand over first to Fabio Antonio from the UXful facility with Sylvain, and they will give you a first demonstration of the usage of Visa.
Right, thank you, Majid. Yeah, I think I will go first, right, Sylvain? Excuse my video, I've got no virtual background. It looks like a virtual background, very spacey. I don't know what you prefer. I could turn that off completely. Anyway, I will now share my screen, and I hope you'll focus on the screen then. Can you see my screen, full screen, and does it look well?
Yes.
Okay. Yeah, so I will try to give the European Exfil perspective. So how to use Visa really from the user's perspective, and with a use case, which is a crystallographic serial crystallography use case in that case. But I will start giving a little bit of context also about the scope and current focus of Visa. So the motivation, right? So European Exfil data is completely in HDF5 format, including the data from the big megapixel and megahertz detectors, which of course create huge amounts of data. When run, how we call it, could already have like 2 terabyte. An experiment over a week could have even a few petabytes. What comes more is these detectors have usually modular geometry and associated to that a special data layout, which needs to get used to. So for training, instruments ask for selected what we call example runs, which are data sets, not mock data sets. Of course, they are real data sets, partly from real post-embargo experiments, partly from commissioning data, and then new users would usually get early access prior to beam time to our high-performance computing cluster, which is at DESI, and free access to these folders with that, if you want, training data. And then typical environments for data analysis are simple secure shell, or a Jupyter Hub, which is also running on that Maxwell on some partitions, and making also use of Slurm for multi-distributed computing, multi-node. And as a remote desktop solution, we have this, what we call FastX, and for running graphical applications. So how do these example data look like? So this is also our starting set of open data that we want to use with Visa. And so this is an extract from that. It's about 40 data sets. It is one, if you want, mock proposal, example data proposal, but with these real data, from covering a representative range of experimental techniques, right? You see some of them here, like serial crystallography, small angle scattering, etc. So the rationale, the motivation is, I think our users that are experienced and returning users are quite happy with the existing infrastructure and services that I mentioned. However, still for less experienced users, I mean, they need to find out about the login, how to get to the files that are interesting, how to set up software in a case, etc., etc. So I think that is really a barrier. And here Visa is already a solution, a good solution, because it combines 2 major services, Jupyter and remote desktop. It's a user-friendly web application in a browser, as said, no extra installations need. it has pre-built from side of the facility, pre-built, whether this is containerized, mounted, or pre-built software, and direct linkage to the data. So this I see as a very much streamlined data analysis procedure. And now I want to showcase how that looks like with our Visa installation, visa.exfil.eu, which is, I should give a heads up, it's already running on production infrastructure and it's kind of a production deployment, but details of how data exposed, I consider this still a bit of a demo phase. So the practical part, the demo part will be 4 modules that are screencasts, okay? And the first one is about the login. Now I hope the video runs as well. So to log in to Visa, this is the homepage under that URL, and you have the option, if you are a DESI, Exfil DESI user, you could have a direct login under sign in. However, we have an AAI system, which is not yet umbrella, but will be at some point. At the moment, it's a Helmholtz AAI. That means there are already a list of identity providers for authentication from which you can select. So in my demo, I will obviously select DESI again, which comes now. And yeah, use my credentials from there. And if I log in now, what the user will see on the home, so it's a key cloak mechanism technically, so you accept the conditions of that, of data transfer information. And this can be saved, so upon repeated login, you do not have to do this identity provider, etc. again, of course. And then you see what is called the instances. These are sessions in a virtual machine that are already existing. If you want to start a new one, like here, you then would select the data you're interested in. This list corresponds to the list from our metadata catalogs that I've shown you before. And you select some of these to work with, but here these are equivalent and all accessible, I should add, because this is really open data. And then it is displayed here, right? And then you would select an environment for the virtual machine. We want to use here this crystallographic software, Crystfel, pre-built, with a default set of for screen and hardware, and we accept the terms of condition and create this new instance, which was just to show you. This shown here as building on top, also with a message on the bottom right. So that was that. So the next module would be first look at the remote desktop and the data. Now it comes more, let's say, Exfil specific also. So as Jean-François said, for this virtual machine, you have two principal modes of services that are integrated: remote desktop or Gitlab, and we will use the remote desktop here. And well, yes, this is a desktop with some popular applications on the bottom and with a file browser and everything that you know or expect. The file system here, that is a mounting of a Dcache where exactly our open data now is stored. This strange proposal path that resembles the structure of how our data at European Exfil is organized. But these are essentially the 40 example runs, of which we choose one. And so this is data from the adaptive gain integrating pixel detector, one of these megahertz detectors. That is peculiar. It has a lot of different files, which are themselves rather large already. Why is it different files? Because each module is by the data acquisition system stored separately, and then even in sequences if it's a long taking of or acquisition of data. So what software wants often is a handy single file representing that data set, and that's what I show you now. Actually, that was too fast. Okay, yes, this sample run VDS, we call it a virtual data set, is a reference to all these big original data, presenting this as a single file. I will show that in the next demo. Next demo is about looking at data and also the detector geometry. And here we will use a Jupyter notebook to show you also this aspect. So the same virtual machine with a funny name that Visa produces. We will select the Jupyter Lab service now, and we will see here there are two tabs for notebooks that are already prepared. First one is very simple, making use of the installed packages already, Python packages that are in that environment for that virtual machine, H5Py. H5Py is a Python package for reading data in HDF5, and this is now opening this virtual data set. And when we have this file object open, there's a tool developed at our data analysis group, and this will display the hierarchical HDF5 structure going down to the detector. And now the detector is really presented as one data set with many frames. Right, 600,000, more than that. These 16 modules are in a stacked dimension, and per module you have these pixel dimensions. So how does this look in practice? There's another notebook now. Again, extra data and extra geom are tools also partly co-developed by PaNOSC funds, and yeah, making really use of H5Py and other libraries to show data geometrically. This H detector looks like this. You see 16 modules that are arranged in 4 quadrants, and really these quadrants can by motors can be positioned. That is the specifics of the detector. So now we want to associate this geometry with the data, and for that we open this run. This is now not a crystallographic but a powder diffraction run. As you will soon see. So if we take one frame of this data set, frame number 10, and then we result with a single image, which is here 3-dimensional data, but this is now assembled as a 2-dimensional image with those nice powder rings, by which you can also see that your geometry is correct, because otherwise they would not align. So the last part, going again to the remote desktop, will show you how to use the Crystfeld software with its GUI front end. So that's why we need a remote desktop. And so we have already a remote desktop here with a terminal window, by which we will now call Crystfeld, which will open the GUI in a window. It takes a second, and here is the Crystfeld main window. So this is already showing one of the first detector frame, which is empty out of this large set of detector frames. I will here in the demo, yeah, make it a bit bigger and zoom out. And then on the left-hand side of that Crystfeld software, you see different typical steps in crystallography. You would first need to find bragg peaks. In order to do so, there are certain peak finding algorithms you can select, and these are some specialist parameters just to show. And then you confirm that, and then, however, we want also to navigate to a detector frame that contains something, which is not this one. And we can navigate to another one. And there are some parts in that video, which is the longest video, that I will also skip. But yeah, this is to show you how this then looks with mount peaks. Right, a lot more going on here, evenly distributed. So this looks like a detector frame that you can index. So indexing is a crystallographic method to give these peaks a meaningful position in Fourier space of the diffraction. We are selecting 2 indexers here, but no prior knowledge on the crystallographic unit cell. And now the added green circles are really these are positions of peaks, predicted positions belonging to the expected unit cell, which is crystallographers may recognize this as a lysozyme, a typical test crystal system that we look at here. And there's mostly also a good match between the real data peaks in the data and where they should be according to the indexing. Now, at this point, I can jump a bit to so this is frame by frame, and you get a first impression of what your data looks like, and it says can be indexed. Now I import some larger output data set from processing, which would otherwise take 20 minutes or so, even on multi-processing nodes. So I already prepared that, and this is just to show you that then, of course, in this data, if it is processed, you find a lot of more crystal unit cells, and the distribution for these looks like nice, sharp, symmetric Gaussian peaks around the expected crystallographic parameters of the unit cell of the lysozyme. And with that data, even though this is even a subset of a whole run, you can in principle do the next step, which is a merging step. And if you did so, I will skip here as well. You could, in principle, then show, again, interesting for the crystallographers, the typical figures of merit, intensity over error, for instance, how complete the data is, even if it is maybe multiple observations, which is good for statistics. And then you will do that. And now on the bottom, you see the terminal standard output of the program here in the window. And your expert would recognize it's probably not yet enough data, even though it is complete. It has not the best statistics yet, but that was just to show you the demo. Yes, and with that, I am at the end. So I hope I could show you how here, as I said, the notebook and the remote desktop integrate, and how you could, with pre-installed software, find a workflow for your needs with the data that you need, that you're interested in, open data for reuse in that case. Yeah, and happy to take questions either now or maybe later, right? I will stop my screen share. And yeah, now I look nicer.
Yeah, thank you very much, Fabio, for this very instructive, clear, and which is in somehow already a show where you covered most of the features provided by Visa. There are already a couple of questions which have already been answered. Some others are pending, and as Kat said in the beginning, we'll keep them until the end of the 2 demos, and we'll try to answer your questions. So now I will hand over to Sylvan. Will you give some other demos or your? Okay, so go ahead. Now yes. The presentation from the demo from Sylvan, where they will show you another way of using Visa, this time linked as a backend to a Slurm infrastructure and using containerized applications with Singularity.
Yes, thank you, Majid, and thank you, Fabio, for the good introduction. I want to show you a little bit how to make use of containers, especially with Visa, and also what you do if you have the need of heavy processing and want to access an HPC or something. So I don't know how many of you have experience with containers, so I'll give you a very simplified summary of how to work with containers. Like in the conventional workflow, you have to install your application with all your dependencies. This can, quite frankly, be very complex depending on the software. and especially if you don't have like the administration rights on HPC clusters. What you end up with are the binaries, which you can then call to run processes or also to start graphical user interfaces. I will have Christopher again as example in this demo. So with the containerized workflow, it looks a little different, not much. Oops. You pull the container from registry, you end up with a container image, and then you can use Singularity, which you need to have installed on your environment, and can execute commands from the container, or also start a graphical user interface within the container. What you end up with is a decoupled containerized environment with its own operation system, where the process runs or the GUI runs. What you have to take in mind is that not your whole file system will be mounted into this environment, but just your home directory and all the paths you manually bind. So what are the advantages? On the pro side, you don't have any installation anymore with the container because all dependencies are already met within the container. You have a high reproducibility. So if you refer to the container image you used, it's clear which software you used and which versions you used. You also don't need elevated rights if you use Singularity. And concerning Visa, you become independent on the virtual machines that are provided by your facility, so you can use any application you want and any version you need. And also, which is important for programs like Christopher, that Singularity fully supports or is fully supported by Slurm. So you can run your Slurm scripts with commands that are executed by Singularity. On the contra side, however, is that you first need a container which you can pull and run. Otherwise, you have to build it yourself. And the syntax also gets a little more complex. And the paths which I mentioned need to be mounted. And last but not least, even though Slurm is supported by Singularity commands, you don't have access from within the container. So if you run a GUI, for example, within the container, it won't have access to the Slurm installed on your host machine, because we have this decoupling between the host and the container environment. To address these problems, we thought of a more streamlined workflow with containers, where you have a configuration file and an installation script, which together will create wrapper commands, which will do basically everything for you and run the container behind the scenes. So the model changes a little bit. You clone from Gitlab the containerized application, we called it. Then you have the installation script and the configuration file. You install or run the installation script and end up with your container and with a lot of web commands. Then you can run conventionally, like if you had installed Crystal, the commands or also the graphical user interface. Additionally, it also provides wrappers for the Slurm commands. So now you are able to run Slurm from within the GUI, which runs in the container. The configuration file is pretty simple. Most important is that you define the container you want to run and also the commands you want to have access to. And one nice thing is you can also define default directories, which will always be added to the commands you run with the container. So to give you a little demo, we start here in a Visa instance, which we run in the browser. The virtual machine we loaded just has Singularity installed and nothing else. So if we try to run Crystal, we won't succeed. So we just pull a Docker container with Singularity, which will be automatically transformed to a Singularity image. And then we can execute the commands with Singularity. Here as an example, Elixir Magic with a very small file list works pretty fast, of course. Alternatively, of course, we can also start the graphical user interface within the container. Now to show you the more streamlined workflow, which gets rid of the additional syntax that comes with the container use. We clone the repository with the configuration and the installation script. It's already pre-configured for Crystal, as this is our test application. The only thing we want to change in the configuration is the path, so we automatically have access to the data we have on Visa and run the installation script so that all the wrapper files are available. And now we have the conventional syntax you know from Crystal. Yes, and the graphical user interface works the same. So now is the questions, especially with serial crystallography, we will have the need to use HPC clusters. The virtual machines in Visa come in different flavors with more or less memory, but it will never be the same like with a real HPC cluster. You have multiple possibilities at DAISY. If you have access to Maxwell, which is not automatically given just because you have access to a Visa machine, then you can either SSH tunnel, like in this example, to Maxwell, or you can also use your browser and log into JHAP, for example. So now we are on a Maxwell node and try to run Crystal. We don't have it, but we just clone again the containerized application, which is again pre-configured. Again, we add a data directory and try to run it. Here's a simple Slurm script prepared. You can see it basically just runs index.magic, the command from the web command of the container. We run the job. Let's see whether it's running. Yes, it is. And the same we can also achieve by using the graphical user interface. We load some data, the geometry file. So now we basically have the graphical user interface running within the container running on Maxwell, which we access through Visa. Why this makes sense is that you have the experimental data you don't have at home, but you have access to it both in Maxwell as well as in Visa. And this concludes my video. Thank you very much for listening.
Thank you very much, Sylvain, for this impressive demo, which shows another way of using Visa with a more flexible way for users to get access to different flavors of softwares they need in a secure, containerized environment. Now we are still on time and we'll hand over to Stuart Count from ILL for the second demonstration.
Thanks, Majid. So let me share my screen. I don't have any slides prepared. I'm just going to do a live demo. Let's hope that this works. Maybe I should have done like Sylvain and Fabio and done a pre-recording. We'll see how it goes. Can you see my screen okay there? All right.
Yes, we can.
Great, thanks. So what I want to say, so for people who don't know me, I'm Stuart Count. I've been working as one of the lead developers on Visa for the last 3 years almost now. So I can't show you really the scientific use cases for Visa, but what I can show you are some of the features that we developed specifically for Visa to help scientists do their work. Now, one of the main things that we've developed, that Jean-Francois already hinted at, was to be able to share an instance. So we like to promote collaborative work between scientists using Visa. And this was really important when Visa first came out of the ILL. So Visa came into production just before the COVID crisis in 2020. And the ILL wanted to be able to keep the reactor cycle going and maintain the experiments at the ILL. So the main solution that was done for this was to use Visa to allow remote experiments to occur. So obviously when you're doing remote experiments, you need to be able to talk to the instrument responsible as a local contact on the instrument. So collaboration is a key feature when using Visa. So let me show you here. So I'm going to do a quick demo of creating an instance and show you how to share with different users. So to create a new instance, and then I search for experiments, which is the first step. So obviously I'm not a scientist, so I don't really have many proposals to choose from, but we use this demo proposal often for demos, so I'll use that one. There you can see it's already been selected here. It's based on the IN16 instrument. It's pre-selected an environment for me with 2 CPUs and 8 GB of RAM. I can always change that a little bit. So for example, I can choose 4 CPUs, 16 GB of RAM. As an admin of Visa, I see some large and extra large flavors available. In general, these are limited to instruments that really need these high levels of performance. So in general, when you connect to Visa and you create an instance, you just see a small and a medium, which are good for 99% of the cases. I can then change the screen resolution. I'll choose one that's a bit smaller here, just for the demo. And then let's see for the keyboard, that's okay. One of the key features of Visa, well, one of the favorites apparently from the scientists, the random name generator. So I can get some random names. Look, Otter, ambitious sweatshirt, that'll do me. I think that's great. So I accept the terms and conditions, and away my instance goes to be created. And you can see here it's been associated with this experiment. So what I can do now while it's building, I can select members to share this instance with. So I can see here all the proposal team members who were part of this proposal. So obviously it's not a real proposal, it's a demo. So you recognize some of the people here. So let me add a few of them to this. They should be receiving emails, I think, now. So sorry, I think during the week I probably spammed a few people with some emails. when I do some testing. I choose Ludo as well. Who else do we have? Majid. Here we go. So all these people now have access to the instance when it's ready. You can see now it's already built, it's already running. The desktop is now available to use. Anybody who's been added to that instance can now see on the instances shared with me tab, my instance that's been created now, and I can now connect to that. It takes a few seconds. So this is the data analysis environment that we have for Visa at the ILL. It's getting a little bit old now. It's 2 years, more than 2 years old now, running with Ubuntu 18. So you can see Alain is connected. Now he's controlling the mouse. He's doing what he wants. So that's great. I can talk at the same time. One of the first things you see is this pop-up which says that the files will be deleted at the end of the lifetime of the instance. And that's not particularly a bad problem, because I'll just take control just for 2 seconds, Alain. I'll take it over. What we have here are two shared network files. So we have the My Home, which is my permanent storage at the ILL. So I can always copy files into my home for my personal files. That will be available between all the instances. And I also have my data. So this is a quick link to show all the data for the proposal that I've been involved with. So by proposal, for example, I've only got one experiment that produced any data, and I can quite easily access that data. And obviously that's available to all the applications, the analysis applications within the instance. Just quickly show you for the applications. So all the Visa comes pre-configured with all the software that you'll need for the ILL. So we're looking at currently it's under the education. I'll show you a new version of the remote desktop that's coming out in a couple of weeks after this. But just to show you that what Jean-Francois already touched on, that there's no configuration, no installation of software necessary. This instance comes with everything that you'll need to do data analysis or remote experiments. So Nomad Remote is the instrument control software. And then while that's so what I can do now is I can launch Mantid. For example, Mantid is one of the main data reduction softwares that neutron facilities, I think it's ISIS and ILL and others have been involved with. That loads up now. What I can show you now is that we can see all the members who are currently connected. So I can see that Alain and Ludo are currently connected to this instance, and we can now work on this data analysis together. So Mantid is using Python. So for me, this is about some knowledge of my Python. Let's see how this goes. So yes, okay. So it's prints hello. Amazing. Now let's say we need to do some real data analysis, and Alain and Ludo's gone. So Alain, you can help me do the data analysis. But imagine that we don't know how to access the data. Or there's some technical problem that we're having with the instance. That's why we also have what's known as the scientific support. So scientific and technical members of staff at the ILL will see the support page available to them. So if I open that in a new tab, I'll keep the desktop open. So this view gives you a list of all the instances which you are concerned with. So as part of the IT staff, I can see absolutely all the instances which are running. We currently have 90 instances running at the ILL. And I can also see whether there is a remote desktop running, whether the user is active on the instance. So if they're active, I can request to connect to their instance. So let's go back to this instance here. Let's say, for example, we've got a problem with Python. We don't know how to do the Python that we need. So I'm going to give a call to Erwin. He's part of the IT staff. So, hi, Erwin, I need some help. And here he is. He's used the support page and he's requested access. So you see, it's not quite the same as being a member, because he has to request access. He doesn't automatically have access to the instance, which is more of a security feature than anything. So it just gives a bit more security to the users, that not just anybody can connect to their instance while they're using it. So I can grant him full access. He's now connected, and he can do all the Python that he wants. There we go. Hello. And again, just to show you here, so the members connected, I can see Erwin and Alain are also connected. And since I'm now free to do what I want, and I'm happy to continue, I can then manually disconnect whoever I want from this instance, and I'm now free to do this, and I know nobody's connected. So there's a lot of security and visibility on who is actually using your instance, because you must remember this is actually using my ILL account. So I don't want just anybody to be able to use this instance. Right, so I've got a little bit of time left. So the second feature I really wanted to show was on the application side. So luckily, Sylvain has already touched on this subject. We're talking about singularity and containerization. This image that we're using here, as I said, it's 2.5 years old, and we developed it. Well, these applications have been developed over time, basically over the last couple of years. Whenever a scientist says, okay, we need this application to be installed, we've added it. But it's not a very streamlined process, because all this software currently is baked into the image itself, which means that when somebody says, okay, I need a new version or I need new software, it means that we need to recreate the whole image, which is time consuming. And it means we can't necessarily maintain multiple versions of the same software on the VM. So what we've done now, we're going towards the singularity, or Aptainer as it's known now, direction, which is common, I think, with most of the PaNOSC and Expanse partners, to be able to allow different versions of the software to be installed, and also in terms of the FAIR principle. So Jean-François also mentioned this, the reproducibility of software, to be able to say that in 10 years' time, software that I use today can still be accessed in the future. So let me show you. So I'll go to the development environment now. This is Visa Devs. This is, let's hope this works. It's in a new dev environment. So this is the new Ubuntu 22 image that we're working on. We should have in production, or at least in a beta version, in the next week or so. So it's already looking a bit more modern. But the applications menu is a little bit different. Already we see that the ILL software is more easily accessible. So a new user coming here will be able to directly go to the ILL software. It's also available under education, so there's no, so if they're still used to that, they can still use that. What you see here is that all the software has a version number next to it. That's because these applications are now containerized for a particular version. And this also, in the case of Mantid, for example, this is extremely important, because Mantid, it's essential that it runs in Visa, but currently I think it's only running on Ubuntu 18, maybe on 20, but it's not running for Ubuntu 22. So with a container, we can create an Ubuntu 18 environment, install Mantid into that, install all the dependencies and libraries that it needs, and then we can run that on even on an Ubuntu 22 or 24, 26, 28 environment, even in the future. So we can keep that. We can keep using that. We see that now the software isn't in the instance, so it's being downloaded from the container registry at the ILL. It'll take us a few seconds, and then it's launching. So now you'll see that Mantid is up and running, and it's usable as before. I can show you that again, because once it's been launched, the first time it's downloaded, but after that it's actually on the instance itself. So the next time I run it, it should be a little bit quicker. Run it again, so it's just running it straight up. There's no downloading involved. So here we go. That's Mantid running. We've also integrated in the applications menu. This is also dynamic. So if we add a new version, add a new application, we don't need to build the new image, because this menu is actually being accessed from a network drive. So we just need to update the files that go into this menu, and automatically that they're accessible to all the users using Visa. And another thing that we have is also we have the command lines already integrated. So for example, fullprof, I think there's an application called WimPlotter. So if I run that, the command line is there. You see it's downloading fullprof from the Singularity container registry, and that's been running. I don't know anything about the application, so I can't use it, but that's just to show you how that loads. And again, if I run it again, there's no download, it just runs immediately. It's the same for command line tools like Pepsi Sans, I think that's one. Again, it's downloaded and then it's available. Pepsi Sans -v version, something like that. Okay, I'm not very good on the scientific use of these software, but I can at least show you how we're using Visa to help the scientists do their work. So that's it for my presentation. I hope that was useful for you and that you found some useful features.
Thank you very much, Stuart. We are even for the colleagues from the community who are discovering fancy new features you've added recently and which are really very interesting for the scientists and even for the IT people when we are supposed to give support to our users. So many thanks for all the presenters. Now we've got to go to to answer the questions that have been asked. So, Kat, I was wondering, I've seen during the presentations one hand that has been raised and I didn't see it anymore.
So there was a hand raised from Marina. Please feel free to re-raise your hand. I also have the option that if you wanted to unmute yourself, once you've raised your hand, I can request to unmute you and you can ask a question directly if you so wish. Whilst we wait for Marina, I think Nicholas has a question he wanted to ask.
Yes, so go on.
Hi everyone, hope you can hear me.
Yes.
I just have a question related to the fact to have Jupyter Hub as a separate service from Visa versus having it integrated to Visa. So I don't know if there's a cost in terms of performance of having it inside Visa or not, or it's more difficult to maintain as a separate service. I mean, what is your opinion on that?
Maybe I can answer this because we were right from the beginning. We were looking at Jupyter Hub and Jupyter and thinking about how to integrate that into the Visa environment. It's a technical problem more than the desire to actually do it. Jupyter Hub manages its own authentication. It doesn't, at least at the time when we were looking at it, didn't have a reasonable API to be able to instantiate its own, well, instances, VMs or containers. So it's running its own separate. It's kind of like a parallel to Visa. When you spawned a Jupyter Lab, a Jupyter Notebook, it would spawn its own container. So it was difficult in that sense to integrate it. It was competing in terms of competing more than anything with Visa. Okay, thanks.
And now I've seen well, it's not really a question from John Halliwell. He's saying that he was very impressed by the whole system, and they give you all his congratulations. Now, if there's no new question, there's a new one from Franz Lang, who is asking what's the capability to update software on an existing machine.
So this is in line with the singularity, the containerization part of Visa that we're working on now, at least at the ILL. I think most sites are working on this as well. That currently, well, the objective of the ILL is that when a new version or a new software is requested, this is independent of the VM itself. So we can build a container as a separate process. We can add that to the menu, which is also separate to the instance itself. It's in a separate storage. So we can quite easily add new versions or new software to the menu, and they'll be immediately accessible to all the users of Visa. Even if they have an instance already running, they should see the new software already in their menu.
Thank you, Stuart. Well, I will give a suggestion. So if there is no new question, please feel free to answer any to give any new question. There are a couple of questions that have been answered directly, but
so we've just had a new question come in.
Yeah,
when the instance has a container runtime installed, what runtime?
Well, I'm not sure. For this, we install Aptana, which is the new version of Singularity. So it's using a Singularity runtime. Maybe one of the other, maybe Sylvain, you know better than me probably.
Yeah, yes, we have the same installed. We have a virtual machine with Aptana available.
Yeah, well, what I was saying is that there have been a couple of questions that have been already answered. Maybe I will try to go through them, and for people who answered them, if they want to add something, or even other people from the panelists, please feel free to do so. Though, so they're having the first question from Jordi Bordera, asking if there's a user-friendly way in Visa to access data from other user facility or other source. And Jean-Francois
I answered not at the moment. This is something we explore inside PaNOSC. And we have people who have seen Andrea and Giuseppe, I think, from EGI. So EGI is setting up its own instance. And we are looking for a way to transfer the data in a way which is convenient from the repositories of the research infrastructures to an instance located elsewhere, I would say. So this is ongoing. That's not simple for different reasons, technically. Currently, for a user, the best probably is to go to the Visa instance of the facilities where he has acquired the data. But we agree that does not cover all the use cases.
Thank you, Jean-Francois. So another question from Jordi Bordera, asking if it's possible in the same machine to have a remote desktop and from it also use Jupyter Notebook. So the VM has access to both things. And Fabio, you answered him. Please feel free to complement if you, or if not, we can just read what you've already answered. It's up to you.
Well, my answer was a spontaneous answer from my user experience so far, even if I might miss something. But I think the question was a little bit, because a virtual machine can have access to both also at the same time, but you would have the one view or the other, right? I think that was a little bit what the question was at.
Okay, thank you. Another question from Michael Hans, asking how is export control answered to avoid technical assistance to embargo countries, entities, and is the sense of dual use proliferation. And Erwan, if you want to.
Yes, I'm not sure to get the question right, but to access the Visa platform, you need an access that has been validated by of course, the institute, but also to access the data, you have a second step to follow to obtain the access to the data. So I hope it answers the question. It's not an open access to the data. You have to show some credentials.
If you have any further questions or you want to elaborate on your question, please feel free to raise your hand and I can unmute you.
So, sorry, Kat, I didn't hear you.
Ross wanted to evolve on his question, he could raise his hand and I can unmute him.
Okay. Another question from Jordi, asking if the user have an easy way to request the Visa instance, that the Visa instance comes with a specific software installed. And Jean-Francois, if you want to comment on it.
No, this is currently contact with the support, so we can prepare some software, and but we are not currently at that level where we ask the users to prepare containers for. So we can imagine that if users prepare containers, they could do it. They can do it in practice today if they have a repository where the container is available. Now this is, I don't know, probably it's better to answer for ILL. I have lots of experience with production. If they've faced similar cases.
Well, yeah, for us, the software has been built up over time. So we had a choice of either providing multiple VMs with different software installed, or installing everything on the same VM. We really wanted Visa to be as easy as possible to use. So in the end, we just put everything onto the single VM. But I think, as we were talking about containers, this is kind of coming to the end of this, that we need to be able to have more flexible integration of applications, and especially when we're talking about potentially conflicting application dependencies on the same system. Containerization just makes things a lot easier. The whole process of integrating new software is streamlined. So it's much more preferable than baking it into the image itself.
Michael Haynes has raised his hand, so I've just asked him to unmute so that he can elaborate on his question, Erwan.
Yes, thank you. Thank you for your answer. My question is answered with this, as far as the access is regulated to users who has to register in the facilities, and the experiments are under export control, then everything is fine. Thank you so much.
Thank you.
Yes, now going to another question from Hugo Chauvet, from Soleil, I guess, asking how do we, all of us, planning to handle the jungle of local package installations needed or developed by users? Do you have plan to use GUIs or other tools that allow reproducible builds? And is there a way for beamline staff to deploy automatically a set of software for their users?
I answered the question.
Yes.
But I think many presentations below have shown the containers. We are all going to containers, clearly,
yes, clearly.
Due to incompatibilities between libraries. And this is a nightmare for people managing HPC or Visa. That is fixed, solved with containers. So after that, it depends on the RI, what is the policy. Currently, this is, in fact, this is when you try to deploy Visa, this is the longest step to get in touch with the beamlines, with the scientists, and to collect their needs. At ESRF, we have opened the door for some scientists to provide their own containers for the users, which is a way to address the question. We try to automate the creation of the containers with the Git repositories, with the CI. So this is ongoing, but yes, we need the scientist and we need the software and the setup prepared by the scientist. But it really depends on the facility and the level of discussion. Please.
I can maybe add a little bit to this for the ILL. in terms of beamline scientists being able to provide software for their users, we're using modules as well, which is a command line tool. When a scientist, when somebody creates a Visa instance, it's automatically associated to their proposal, and they can quite easily on the command line select an environment which is associated to that instrument, and they get a set of I think basically it's some environment variables, so they get software scripts and things that are useful for that beamline automatically added to their command line. So that's one extra thing. As well as the containerization, there is also this flexibility by the scientist to provide scripts and things that help the users.
Thank you for these precisions. So there are a new couple of questions. One asked by France Long, asking if keyboard shortcuts work on the machine. And I'm seeing that Fabio is already trying to answer him directly. So
yeah, I can do it in speaking, of course.
Okay.
Maybe I will post it then anyway. Well, for me, so for the demo preparation, for instance, the copy paste also from outside the virtual machine just worked. I wanted also to write that there is an info icon on top of the Visa, which gives you much information, also keyboard shortcuts, etc. And maybe there's more to that Stuart also could add. Yeah.
So yeah, the cut and paste, yes, it is integrated into Visa. Maybe if I just super quickly, can I just quickly share my screen to show how that works? Would that be okay?
Yeah.
Let me just quickly share. Sorry, 2 seconds. So I go to this instance here that we were working on. So here we have the clipboard. So if I copy this, so Control C inside the instance, the clipboard then shows what I copied, and I can then cut and paste that using the local keys for the instance. And then I can paste that into a text edit, for example, here. So it's not super streamlined, but it is possible to cut and paste between the instance and the local machine.
Yeah, it's not really streamlined, but it's not really so that complicated.
We hope so.
Oh, thank you for your answer. There's a new question from Fania Turner from STFC, asking if anyone can use Visa, access all the data, and where are the data sources? Are they from all the facilities using Visa? Well, I don't know who can answer, but this is a question going beyond Visa by itself, because
well, I think it's probably dependent on each facility. So the aim, well, at least at the ILM, and I presume it's the aim for all the institutes, is that the users can access always their data at each individual facility. And what Jean-François mentioned, I think previously, is that the multi-site access to data has yet to be fully addressed. But at least you'd have access to your own local data at the institute.
Thank you. A new question from Hans Christian Stadler. Is it possible to put GPU apps into these containers or MPI applications? Jean-François?
Yeah, I was starting to reply. Yes. But you need to take care. If you don't have GPUs or MPI application, this is very special cases. Because if you don't have them, you really don't have to take care about compatibilities between the software which is inside the container and the system that is hosting the machine system. In the case of the GPU, by themselves, that's not a big deal. It depends where but it depends more on the CUDA libraries if you use them. So you need to take care about the compatibility between the libraries. But it's absolutely possible to put either the libraries inside the container or to bind with the local ones. So that's one thing. Regarding MPI, there is also a compatibility. So you need at least that the major version of the MPI used is the same on the machine and inside the container. But there is some good documentation around these two aspects, and yes.
Thank you, Jean-François. Now, I'm seeing Nicolas Soler raising his hand, so.
Yes, I just have a question related to provenance. So is it possible to extract provenance data from these containers, meaning which software and version has been executed for the user to keep a trace of it? Or if not, is it possible to keep a PID, a persistent identifier of the container that was used?
Well, in the case of the ILL, so the objective, as I showed in the demo, is to always show the version of software that is available. So in the menu, you'll see which version is available. We will always keep these versions for the future. There's no reason why not. We can always have them accessible even in 10 years' time, I hope. But to get the information from the container itself, I'm not sure. Maybe Sylvain or somebody else would know more specifically about Singularity.
Maybe the question was just could we put, if we have the repositories, could we put a DOI on the different versions? Right. I think this is a really good idea.
Instance, yes.
Yeah. Sorry. Yeah. Okay.
Well, thank you again. I think I will not have time to go through all the questions that have been already answered. I'll just take one, and afterwards I'll let Kant explain that. Anyway, everything is registered, and people who are attending will have access to all the questions that have been asked and to the answers. So I'll just take a last one from Anton, who was saying that perhaps we have to explain how a Visa VM is different to, for example, a FastX connection. By saying Daisy already uses FastX, which lands one in something very similar to an empty unitary mode desktop. And I've seen that Erwan and Fabio answered him. So Erwan, if you want to.
I've tried to give answers. Actually, Visa is using the technology comparable to FastX behind the scene. The idea of Visa is not only to provide an access to a machine, is to provide the machine itself. So to create it, depending on our needs, to integrate all the needs we need to do the analysis in the VM. So we prepare everything before the creation of the machine. So I think the main difference is that with FastX, you have to find hardware and prepare the hardware, the software, and so on. And after that, you can connect. While on Visa, you make 3 clicks and you already have everything in place, the access to your data and so on.
Thank you. So we're almost done. I've seen one question from Alan, which have been answered directly. So I'll take the last question from Brian Lindgren Jensen, which is not really a question, just a comment from ESS on containers. He's saying that another advantage of the container approach is that it allows for easy grouping of software packages versions. A user easily can select the same software suite that was used at a previous run cycle to allow for easy reproduction of data sets. Yes, definitely yes, you're right. And I think, Stuart, you already given a demonstration of
yeah, that's true. This is exactly what we want reproducibility of results in N years' time. You can still use the same software. So exactly right.
I'm seeing Kat, you want to add something?
Yeah, and also the point that Brian made, and also Stuart, from the fact that it's applying the third principles, which is fantastic.
Thank you. So we are done. We are really on time to finish the session of the morning. We've got 1 hour for lunch, and we'll start the other sessions at 1:30. So thank you for all, for the presenters first, and for the questions, which were very interesting questions and even remarks that give us ideas to continue forward. Thank you. I'll hand over to Kat to conclude the morning meeting.
Just echoing what Majid said, thank you very much for the interesting discussion and all the presenters for their insights into Visa. And we look forward to seeing you after the lunch break at 12:30 UK time, 1:30 European time for the next session, which will be chaired by Patrick Foreman from DESI on the Visa deployment and further development. Enjoy your lunch and see you soon.
Bye-bye. Thank you.
Kat, will there be some introductory words from you, or shall I start in a minute?
I'm happy for you to take over at 12:30.
Okay. Okay, I'll do that. Okay, it is 13:30 in some areas of the world. So welcome back to the second session of the Visa Portal Deployment and Development meeting. So first of all, let me introduce myself. My name is Patrick Foreman. I'm the expense coordinator. So let me thank the speakers from this morning, especially Jean-François, for introducing PaNOSC and expense, so I don't have to do this anymore. And I think the demonstrations have been really great. So I hope we could convince the audience that we are talking about an extremely good product. So we will continue. The second session is split into two parts. First of all, we will continue very short presentations on the deployment of Visa, and there will be, I think, one from Ludovic on the development. And that will then be followed by a roundtable. I will introduce the roundtable participants afterwards. So for now, the presentations will be by ESF Jean-François, by Eric from Soleil, by Tim from DESI, Henrique from Alba, I can't see him yet, but hopefully he's coming, and either Giuseppe or Andrea from EGI. Good, so I would suggest that we begin, not to lose time. Jean-François, are you ready?
Yes, I think so. I'll share my screen. I have very few slides, but I think for this afternoon, what's really important is the discussion that we'll get on the future after PaNOSC, and quickly after there will be the end of Expand also. So what do we do? How do we work together? So here I'm just presenting where we stay at ESRF with Visa. Sorry. So the work done for Visa has mainly been done inside PaNOSC and in WP4 and WP6. We did not contribute to the development of the software. To be clear, we have used the solution as provided by the ILL. So currently, we are in a step where we are discussing with the beamlines, but the infrastructure is ready since January this year. It is based on Openstack. We keep up to date with Openstack, and basically what helps us a lot is the fact that we use Ansible for doing the upgrades. This is a fully high available solution, which is shared between 2 data centers. This is not a huge solution for now. The question for now is really to bring the beamlines, to bring their softwares, bring their processing inside Visa. So we have only 2 machines for Visa. This is quite large machine, but nothing. This is 2 terabytes, 64 cores, and 2 GPUs, 2 A40 per node. We have set up, and I will talk a little bit after that about it. We have set up a small HPC solution based on Slurm, where we have 6 physical nodes. And here again, we have 2 GPUs. On 2 nodes, we have 2 A40 GPUs. For people who are not very familiar with the NVIDIA products, currently the top of the game is top of the product is the A100 with 80 gigabytes of RAM. Here, this is machine just under this type of products with just 48 gigabytes of RAM. It's quite important for us. This is the RAM we are looking for, more than the computing capacity of the GPU. We use Gitlab as a SSO, like for all ESRF applications. From the nodes, we can access the storage. This is the central storage of the DSRF. Through the dedicated gateway, which propose only NFS v4 for now. The machines are connected with standard Ethernet links, 25 gigabits per second. Currently, we are deploying with Ubuntu 20.04. Sorry. 20.04, and we are preparing the migration to 22, which will happen probably in October, November. And like all the others, the Visa application is running in containers as they are delivered by ILL. Since then, we are fighting. I don't know if fighting is the right word. Fighting for the time of the beamline scientist. We need the help, that's for sure. We need the help of the developers also, developer teams, to set it up. And we are preparing a general rollout. So the Visa is available. The interface is available on the internet since some time already, but we haven't communicated a lot with the users. A bit more detail on the GPUs, because I don't think that I've looked at the presentation from this morning and I haven't seen much people talking about GPU in the VM. So this is what we have done. There is a clear need due to the softwares that people request. I would say this is more exploratory for now. We are not sure that's the right model. The problem I have with that is that GPUs will be stuck in the VM even if the VM is not used. Regarding the cost of the GPUs, that might not be the right model. But as we wanted to attract the maximum of scientists, we have a beamline, we have done it. But we did not request the modification or try to modify a Visa for that. So as you will see, it's a bit ugly. We use the title of the flavor to inform the users that there is a GPU. It's not ideal, but That's the way we work. In order to do that, so we have one GPU. This is really the physical GPU which appear in the VM. So one GPU for one VM until the VM is deleted. And we manage that through an OpenStack component called Cyborg, which is very convenient, very clean, because seen from Visa application, this is just a new flavor, sorry. Like the one where you set only 8 cores or 16 cores. So on the Visa side, it's very easy to handle. Another thing we have tried also, what I'm presenting here is really what has been, is the result of the feedbacks from the beamlines. So they have some processing workflows, they have some software that need either MPI, either a certain number of cores, and they need HPC resources. So we have set up, the choice was to set up a small Slurm cluster dedicated to Visa and not mix it with the internal Slurm cluster, the large one. On our internal cluster, we have something like 6,000 cores for now. And then we need to extend it. One of the problems we've seen with that is that we need the internal cluster is used during acquisition, and we really need to have it not disturbed, I would say, by Visa activity. So we have separated it. It's on a separated network, like it's in the same VM as the Visa machine VM. For those who know Slurm, the VM are in configless mode. So it means that the configuration is sent from the Slurm controller. This is one of the options. And as I said, we have only 6 compute nodes at the moment in Slurm with some GPUs. So I will conclude on the next, what is coming next. So we really have to open all to communicate and open Visa to all the users, even if we haven't collected all the software from the beamlines. Beamlines are very busy. We have difficulties to get time with them. Some of them are using their own code, which is not in a repository, a standard repository for ESRF. This is quite difficult. So we turn the problem around, and now we want to open to the users and let the users request the softwares. Else we could be in the same stage in 2 or 3 years without much progress. We estimate that we have more than 100 software, and we want to move them to Singularity. So this is not only for Visa. Singularity came because we have some contact with a GSI, which is a research center in Germany from the ION community, where they use Singularity a lot. And this is where we pick up Singularity. We expect to use Singularity also for the internal Slurm cluster. So we use the same code for Visa, for the Slurm clusters, but also for the beamline machines. When on the beamline machine, they are running some data processing. So this is a big move for us, which is not completely easy. We work with the developers. Developers sometimes do not. It's difficult. Huh? You are working in a way since 10 years, and here you have to produce something different. So it will request a bit of time, but I think that this is in the interest of all of us. What needs to be done is provide clear documentation. I've been contacted, or we are contacted from time to time from people interested by the GPUs or the Slurm cluster, or what we do with Singularity. So I think need to be discussed with the ILL, but this could join probably the fantastic documentation that has been done on Visa. Need to be discussed. We have also some requests for Windows software, and that's a bit tricky. We have started to explore solutions. we were thinking about using remote desktop solution. It does not work well on with a main interface on Linux. We have explored different solutions. Currently, we are working on providing Windows VM instead of Linux VM, or not instead, but alongside Linux VM for this use case. There is some reasons behind. Typically, the way you access the data is not the same. So we are trying this solution, and we will see where we arrive probably in a couple of months. There is some question behind the authentication. Deployment of the Visa stack is not so difficult, but there is still some problems. We have also to work on the way we distribute the beamline scripts. So most of the beamlines have their own way to welcome their users, to provide some script, some bash RC, some octave RC, whatever. This is something which is not very clean for now. There is the question that was raised by Jordi, which is, do we want to open to non-ESRF users? So to the community at large, I would say. And currently it's only for the ESRF users. This is a real question. This is a management question, but also a technical question. For Visa, I don't think this is a big deal, but Stuart will probably answer. This is probably not a big deal to open to non-user facility, the users of the user facility. But at ESRF, for instance, the data stay on disk for 90 days. After that, they are moved to tape. So we need to find also a way to get the data back to disk. There is some work behind it. And as usual, we try to listen to our users, and there will probably we will probably have a task list which will increase when we open it. Thank you. That's all for ESRF.
Okay, thank you, Jean-François. Unfortunately, we are running a little bit out of time, so let us postpone the questions to the end of this session. Good, so next up would be our friend Eric from Soleil. Eric, are you ready? We can't hear you yet. No?
You are muted, Eric.
Yeah. It's better now. Try again.
Okay. You hear me?
Yes, all fine. We can see your slides and we can hear you.
So can you see the right screen?
I can see Visa deployment at Soleil.
Okay, thank you.
Go ahead, thank you.
Sorry. So hello, everyone. I will present you the current Visa deployment at Soleil. Starting with a quick reminder of the resource lineup at Soleil, and then going into a short description of the Openstack infrastructure we set up for the demonstrator. And then we'll get into the Visa integration, the Visa image building process, and the current state of the project and what remains to be done. Starting summer 2021, our team objective has been to set up an analysis service prototype in the scope of the WP4 deliverable D404. And Soleil resources at the time was on the WP4 is Majid as a co-leader of the work package 4. Alain Buteau is the IT infrastructure manager of Soleil. And Ryan and myself, we work as a system and development engineer. Ryan and I have been working on the WP4 project since last summer and gradually been assigned full-time on this task. Regarding our technical knowledge, it has been a great technical challenge since we didn't know anything about container technology nor OpenStack at the start. Jumping onto the project, we had to consider a few options given the time frame to mock up a prototype and the available human resource and computer resource assigned to the project. Setting up an expand prototype in 8 months with a solution coming solely from Soleil was very ambitious. Therefore, we decided to rely on existing solutions at IDL and Dizzy using Visa and OpenStack. For virtualization, we have a good experience of Proxmox and VMware hypervisors at Soleil, but we decided to go with Visa for its scalability, OpenStack for its scalability and heterogeneous integration capabilities. and for its VM and bare metal provisioning features. So we consider that OpenStack would be the most flexible solution, admittedly at the cost of its complexity of implementation. For the web service providing data analysis, we decided to go with Visa since it was, to our opinion, the most mature, reliable, and documented service available, and it was already in production at high level. For our demonstrator, in terms of hardware sizing, we decided to set up 3 stacks that will allow us to have a stable physical stack dedicated to the demonstrator, a smaller physical stack dedicated to development, and a virtual stack that has been purely used for OpenStack Visa deployment tryout at the early stage of the project. Prior to deploy, we had to consider the architecture, since we didn't know anything about OpenStack, and the available OpenStack literature regarding design, as known as Architecture Design Guide, is obsolete since 2017 and do not cover current architecture done by deployment tools like Openstack Ansible or Ansible. However, some content remains useful for understanding OpenStack features as a storage, instance storage solution, control plane architecture, etc. For the OpenStack deployment, we experimented different scenarios using a manual method. It was long, complex, and practical, and reproducibility of the deployment scenario requires an intransigent rigor. So we dropped this solution. Then we switched to OpenStack Ansible. It's an automated deployment of OpenStack services in LXC containers. It's not as practical as we initially thought, since multiple OpenStack services are grouped in LXC containers. So maintenance operation of a given service impacted all services within the container. Then we switched to Ansible. It's an automated deployment within Docker container. So each OpenStack service is individually containerized, and configuration provides good granularity capabilities. So for instance, we can define on which node a given service will be hosted. So other deployment solutions have not been evaluated at Soleil. We didn't have time. So currently, we are using Ansible, since it allows great flexibility in architectural choices and simplify OpenStack service operation. We are able to redeploy a full OpenStack in less than 2 hours, and reconfiguration is usually taking less than 20 minutes. Ansible also includes maintenance tools like Galera cluster recovery playbook that we had to use 2 times when we were in disaster situation. Here is just a screenshot of Visa instances within OpenStack. So that's the OpenStack view from Visa instances. Sorry, I'm missing a screen, I guess. No, here we are. So aside the core OpenStack infrastructure with the 3 control nodes and 3 compute nodes, we have also a storage server providing file system through NFS, and an object storage service using OpenIO for test purpose. The latest was used to test OpenStack Swift service, and is not used in our current deployment. Also, we have a 2-node Proxmox cluster hosting the machine running Docker containers for Visa services, Gitlab, traffic, etc. And also the utility machine used for OpenStack administration on each stack. And a machine also dedicated for, well, actually 2 machines dedicated to image building process with Packer. So OpenStack internal networks are on dedicated 10 GB switches, each node is connected with dual 10 GB interfaces, aggregate per network. The public traffic is done through the classic Soleil experiment network backbone. Visa has initially been deployed with Docker, as we quickly switched to Docker Compose, which make it easier to manage Visa application, API servers, the web UI, the Jupyter proxy, etc. Visa services are behind a reverse proxy. We use traffic since it's well designed for containerized services. It allows dynamic ports, loaded node containers, etc. And for the ease with a traffic configuration file. It's a YAML file. It's very simple to use. Visa authentication is done through an IDP, namely Gitlab at Soleil, which is linked to our experience network directory. It's a classical LDAP directory handling Soleil staff and beamline user and project information coming from the user office application. Visa application and its dependencies, Gitlab, etc., are hosted in a Proxmox, as I said earlier. but we currently have no load balancing nor high availability features implemented. Also, the ETL is not implemented, so we have no interface with our user office data. Here is a screenshot of Visa instances, just a sample of Visa instances running on our proof of concept on our demonstrator. And here, that's the admin view of Visa. That's what we see as an admin. And here we can see an error when I try to run too much machines. OpenStack returns an error. The image building process is now automated, fully automated. We have defined a GitLab pipeline for the project, and 2 runners are defined. So the image, the Visa image template directory containing system-based, Visa-based, and Visa apps are committed in a GitLab project. On each merge request, the pipeline is staging the jobs, and the build process starts through the runners. We have 2 runners, one for each build machine. At each stage, the OpenStack image is created, for instance, system-based, and then it's spawned on the OpenStack. The second stage uses the image as a base, and so on. If the build is successful, the process ends up with the Visa image app deployed on the OpenStack, and it's available for use immediately. So we use HTML2 language instead of PaCMe, which we find easier to configure. To me, at least, it's less prone to syntax error. Here is an example of the GitLab Visa image building process at Soleil. And here it's a view of the failed job in the GitLab pipeline. So the build deployed logs allow us to quickly identify the cause of the failure. So it's a really great tool. The current Visa platform is a demonstrator-grade service. So it's only for prototyping. It's only available internally for testing purpose. It provides mainly 2 system versions, Ubuntu 22.04, also 20.04, and also Debian 11. GPU are supported. We currently can have up to 4 GPU in a single virtual machine. We have 2 A16 cards. So access to Soleil storage is available. So each logged in user has access to its data of experimentation in which he participated. And software integration are in progress. We work closely with the data analysis team in Soleil to integrate their applications. So we currently provide a MATLAB, Jupyter Notebook, PaNOSC, which is a Soleil application built by Samba Beamline. We integrate also Conda, NextPy, and some other tools. IDE also as a Visual Studio Code. So here is an example of XAFS, X-ray absorption, fine structure data treatment Soleil software developed at Soleil on Samba Beamline. You have the link here if you want to find the software. Here's a sample of a MATLAB GPU benchmark on a Visa instance. So right now our GPU are not really powerful. What remains to be done? First thing to do with Visa that is really important would be the ETL, to inject experiment project information needed to the to the user to retrieve its environment. Well, actually, its data. To start, we will use the experiment project information that are available in our LDAP directory. But at this stage, unfortunately, the container information is not necessarily reliable. So we hope to be able to access user office data through an API in the near future. Regarding production grade service, we have planned to put on a load balancer and HA capability in front of Visa using traffic or HA proxy. We are still evaluating that right now. We will also provide AppTainer Singularity runtime to host containerized application. That's a must do. And also the other plan is to migrate Visa services and dependencies from Docker Compose to Kubernetes. We need to define also a strategy for machine type and software suite. So we will work closely with the data analysis group to clear this out. So do we want, for example, an all-in-one machine with all the software included, or specific machines for each beamline or each type of treatment? It's yet to have to be defined. Regarding OpenStack improvements, we plan to integrate ironic for bare metal provisioning capability. We will probably look into Cyborg too. We have to implement also centralized logging, since it's preferable for debugging efficiently. We will go with a classical logging mechanism using rsyslog. At this stage, there is no plan to use Elasticsearch that Ansible is actually capable of deploying. Progressively, we'll migrate to production-grade hardware. So right now, it's just recycled machine that have been put together to set up the project. So we need to have machines under warranty, performing GPU, high-speed file system available also. We have to define also an update strategy and support strategy for operation, for the IT team operation. That's it. I wanted to thank you specifically, Jamie and Stewart, for the help on Visa, and also Michael Schwartz and Patrick from DAISY that have been a great help with OpenStack and Visa integration. So we hope to expand this collaboration with other people from the community, and it has been a very great experience working with ILL and Visa and DAISY. Sorry. Thank you.
Thank you very much, Eric, and not to forget Tim Wetzel from DAISY, who by accident will be our next speaker. Let us move the questions to the end because we're running out of time. Okay, thanks again, Eric and Tim. Are you ready?
I hope so. Can you hear me?
Yes, yes, we can hear you. Eric, would you detach your screen?
Sure. I don't know how to do that. More. Leave.
Or I can just steal the screen share.
Okay, just steal the screen share.
Oh, stop screen share. Oh, I got it.
Okay,
thanks.
Great. Okay, so our next speaker is Tim Wetzel. He is working at the Research and Innovation team at DAISY IT.
Yes.
Go ahead, Tim. I can see your screen. It's all fine.
Good. Very nice. So thanks for having me. I will just briefly show how we deploy Visa at DAISY. And my slides are going to be a bit shorter, maybe. So I wanted to focus on what we do differently and have developed so far. So having OpenStack is nothing new in this context. So we obviously have an OpenStack instance here, which we use for Visa. But on top of OpenStack, we run a Kubernetes cluster on multiple ones, but especially one in which we deploy Visa. And I'd like to show you how we do this in a continuous deployment fashion. So I'm going to be going more on the architecture side here. For the continuous deployment, we are employing a piece of software that's called Flux CD, which is taking care of keeping all the deployments up to date. And these deployments of Visa are defined in value files that we host on our GitLab instance, which is also running on OpenStack. So there we have, for one part, a repository with Visa Helm charts, which were developed by Michael Schwartz to make use of the ILL-provided Docker containers. And for the deployment configuration, we use another repository which contains the values that are needed to really deploy this. So I'd like to quickly switch over to the GitLab repository or the GitLab group we have. I hope you can see now a GitLab screen.
Yes.
That's not very good. And there we have the Helm charts, which allow to have a recipe for a Kubernetes deployment. And this is containing a values file in which we can configure a lot of components. So the web container, and you see we're just pulling, for example, in the Visa web container or for the Visa web application, we're just pulling the ILL container Visa web and deploy it on Kubernetes. I'm just going to go into the templates here quickly. You see for all services and needed Kubernetes objects, we have a single YAML file, which is templated and then combined with the values so that we have a full API object description for Kubernetes to deploy. Let's see what might be interesting here. Maybe let's go with the web server again. You see, you can select on which kind of Kubernetes node this is to run, which container is going to be used, and all these double curly braced entries are templated values which will be merged with what we provide in the configuration data. Another thing that's interesting, and his name has been mentioned before, we had Ryan Persay from Soleil visit us some weeks ago. He did some work on this too, very great work indeed. And he reworked the Helm charts again. And what he did, what I found very interesting and very good, was that he, let's say, factored out the proxy container into the Kubernetes ingress controller, which happens to be an Nginx web server as well, so that we have to use one less component when we deploy this on Kubernetes. Okay, I'll take any questions later on happily, but now let me switch back to the overview that I hope is going to make a bit more sense in a moment. Now that I've showed you the Helm charts and the values just briefly, these are merged into Flux automatically. So if we change anything in GitLab, Flux notices and updates the release accordingly. And the containers are obviously, as I said, pulled from GitHub, from the ILL repository. And with these three components in the background and Flux, we can then deploy the Visa portal for Xfel and a Visa instance for DAISY as well. Now, the last part we have is obviously the data that we need. So all proposals, experiments, run data. These are stored on Dcache and can be NFS mounted onto the VMs that are spawned by users when they log into Visa and log into Visa and spawn a VM on Openstack. So there's the normal plugin, the provider by Visa, which spawns our VMs, and they just mount the data, and every user gets the proposal data or run or experiment data they have access to directly mounted into the VM, so there's no confusion about who has access to which data. I think that's maybe it for this short demonstration or short show. If you're interested or if you have questions, please feel free to ask them later on. One question I would like to ask is, as we're maintaining the Helm charts for Visa at the moment, is anyone interested enough so that we have to publish them, we should publish them on GitHub for you to have a look at or use them maybe? That will be what I have for now. So thanks a lot, and questions for later. Thanks.
Super, Tim. Thank you very much. And thanks for catching up with the time. Good. So moving on, and I see that we have Enrique now, just in time. Are you going to give the presentation, or Gabriel, or?
Yeah, I am going to do a demo on the presentation.
Okay, perfect. Okay, so go ahead.
Yeah.
So while Enrique is preparing, I can just give a context information on this demo. So this is Visa running on Kubernetes at Alba. This is a prototype that the computing division at Alba has made. And so if everything goes all right, Enrique will show you how to open an application for infrared spectroscopy, an orange workflow, more exactly, using Visa. Enrique, the floor is yours.
Okay. Hi. So
Eric, we can see the presenter view. Maybe you can swap.
Ah, okay. Yeah. Sorry.
Yeah.
I'm gonna. Let me see. I know it. Let me change screens.
Yeah.
Okay, you cannot see it still, right? Yeah, okay.
It's
Okay, I'm gonna show you like this.
Okay.
And the main issue in Alba was about the cloud provider. We are not going to use Openstack, so and neither Proxmox. So we started with two options, with it is Citrix and Kubernetes. Citrix we already had in Alba, so we had some experience in it. But implementing in Visa was harder development. So for now, we are using Kubernetes, but Kubernetes does not support Windows machines. So in the future, we have this main issue with Citrix that we will make like a dual cloud provider with both technologies. For now, we have Kubernetes to make pods that are exposed via NoVM VNC, and we can see it in the website by HTML5. This has some security issues that later on we will discuss, but for now I'm gonna show the demo about like the first approach we managed to do with Kubernetes. So the process is the same, and for now we can create selecting the chosen experiment, the associated machine. And well, since it's not a real VM, it's a pod, it has some issues with the state, but for now we managed to open the pod from Visa, and here when it initializes, it's a really big image, so it takes a little bit the first time. So you have to wait a little bit. And now Gabriel is going to show you a real like experiment in this machine.
Well, it's just a small example of the here in this pod we have installed Quasar. Quasar is a graphical application to define workflows, and I can show you a couple of workflows. One of them is an actual workflow used here at Alba for experiment. Here, when we open Quasar, Quasar is installed in the pod, but the volume I am seeing here is a volume from our storage system, where I have access only for the data I have as a user. And just a second.
Yeah, you have to go to the main. Okay.
Yeah. Here in the beamlines, I can go to my projects. And as you can see, I can only open my proposal where I have the data and the workflows. This one is from actual data with actual workflow. Which I can open with Quasar. Okay. And in here you can see just a data workflow with a couple of samples, one from dry cells and the other with wet cells, comparing the the behavior. You see the red dots of the workflow running live. And we can also see, for example, some of the spectra here. But okay, I don't want to go in detail. I just want to show you that we are able to run a Visa, having an instance running on Kubernetes, and that this is a little slow. And this instance is running data that is from our storage, and the permissions in this part is running fine. I think that's all. You can take over, Enric.
Yeah, okay. Yeah, so having discussed the main structure, as we have said, we have different issues and improvements that we need to start developing. The first one is, as I said, the combination of VMs of Windows and Ubuntu with Citrix and Kubernetes. And the other main issue is about security. As you can see, there's the pod here. When you have from inside Alba, you could like do a port scan and have some sessions security issues or session stealing. So that's a thing that we can fix that using Guacamole, for example, or having passwords in the pod that we need to investigate, which is the most secure way or most useful way. Also, we have some data management access to store data and take data that it's been modified using Visa. We have some service that we used previously in Calypso. So we can use this to access our data. For now, it's just like hard-coded for me. So we have to make different users that can access only the data and stuff, and also make this non-visibly for the user, so the user can make his custom machine and just being provided with a service without him knowing like what's behind with two Citrix, well, two providers and all that. So yeah, that would be all the presentation. I don't know if you have questions.
Okay, thank you, gentlemen. That was a very nice presentation, especially the demo. As I said, I would prefer to have the questions afterwards. So next up, and the last in the series of deployments, would be EGI. It's Giuseppe or Andrea.
Yes,
you are
yes.
okay, super. Thank you. So go ahead.
So good afternoon, everyone. I'm going to start slideshow. Can you see the screen?
Yes.
Okay, thank you. So I'm first I'm going to start a couple of slides describing what is the GI infrastructure. Just want to say where we deploy Visa. So we have it's an international infrastructure that is the operation is coordinated by AGI Foundation, and in particular we have a federation of cloud providers, among those infrastructure in the HTC and Cloud Resource Center, where we which are basically running Openstack, and we call it the AGI Cloud. And this particular infrastructure that is basically delivers, like as I said, all the sites are kind of independent between each other, but we have a series of components that make like a federation of cloud provider easier. So starting from check-in, which is a service that is delivering authentication authorization. We have common monitoring, a configuration database which registers all the providers and the endpoints. So common software distribution with like CMFS or AppDB, which is a service that stores the cloud images. Accounting, so a series of services that brought together the different providers. And among those, just because this is part of also the PaNOSC work, just want to say that check-in is quite important, which is the service that allows the federated access via federated identity. This is the latest version that has been put in production now is also based on the Keycloak, so a standard and industry standard. And we have done the integration with the PaNOSC community AI, which is Umbrella ID, which means that, of course, by using this service, and you could also log in to AGI services using the Umbrella AI. So then starting with Visa, so we have this activity started in collaboration with PaNOSC to demonstrate that the deployment Visa outside of the PAN facilities. We would like also to see if we could exploit the platform outside of course, of the PAN facilities by engaging other communities and also using it in project where also AGI is involved. We have selected in this particular Fed Cloud deployment one site, which is SESNet in Czech Republic. This is something that it's easy because SESNet is also providing resources for the PaNOSC project. We are a dedicated tenant for this. This is the endpoint that we had at the moment for the demo installation. So the first step that you're done, so we use all the Docker Compose installation has been available by LL. Initially, we wanted to install integrate directly AGI check-in as SSO, but then we moved to it. It was like we had some issues, so we tried to move. We moved to the deployment of Keycloak and then integrate Keycloak locally with the AGI check-in. There were some. We have also a small problem. One of the previous Visa versions about the other cases were contacting the Openstack API that has been quickly fixed by LL team. At the moment, in our case, we don't have a TL place because we don't have a facility. So we have basically we configure manually the database in order to give rights to users to access the instance. I see that this week has been released also a new version of Visa, which allows guest access. So this is something that we need to investigate. For the Visa build images, we use the template provided by LL, and we build locally initially, and we use VirtualBox builders. For the integration, so as said before, we try to integrate AGI check-in, so not the production instance for the moment because it's a demo instance. So we use first we tried with the development and then with the demo. We want to use also this AppDB, which is this service which stores the virtual appliance. So we build the images and we publish it there, then synchronized with all the possible clouds that are using that are basically part of this deployment. Of course, in this case, we have only one cloud which is supporting this, but in the future we may want to have like multiple clouds deploying it. With in AGI, we have also the content management service, which is based on CMFS. We would like to test and integrate this in Visa as well. At the moment, we are testing and accessing directly Stratum 1 for an existing repo for testing. But we know that SESNet we have also Squid proxies available, so we can configure also the Squid proxies in order to access CMFS, and then of course create dedicated repos for Visa software where we could publish the needed software and made available to the VMs. And what we want to do next is access to the GPU. So building using images that are ready with the NVIDIA drivers pre-installed, and then of course we need to discuss with SESNet to extend the deployment with the GPU enabled nodes, which is not there at the moment. And then of course data access, which is quite important, and we have different solution available at SESNet. We have the S3 object storage. We have one data with the AGI Data Hub, which is also locally provided. There is also a cache installation at SESNet that we want to use. At the moment, we discussed with them that this is dedicated to grid workflows, so and energy physics. So, but we could also discuss if we could also use the cache for this particular purpose. And for our possible usage scenario, so basically we see this deployment as possible solution for communities that they need to access via demo desktop, a cloud-hosted solution. For the access via Jupyter Notebooks, we are already a dedicated service for this, which is the GI Notebooks, which is based on Jupyter Hub. We have already this kind of project where we deliver data analysis and we have to provide access to cloud and virtual machines via XRDP. But of course, for instance, one of those is the Lite project. Of course, there are a lot of drawbacks with what we do now. For instance, we don't have like so we set up like specific virtual machines for specific users. We have like we don't have VMs like site management. Also, the access via directly via XRDP, we cannot do it, so we have to do SSH channeling. So of course, it's not the best. Of course, if you want to use Visa, then we will need to, for a more general solution for other communities, we need some customization because we don't have the concept of experiments or user associated experiments. So there will need some customization that we need to be done to the current solution. So just to conclude, so basically, for sure, we didn't have major issues in deploying this demo deployment at CESNet. Of course, we know that when moving to production, we will have different requirements. So we will look for different and understand if this deployment that we are doing now is good for production, or we will need to adapt to other solutions, like for instance having the Kubernetes-based Visa or other. We would like to complete the missing integration this year, so to have like or at least part of them, and then showcase the deployment to the interest communities. One thing that we would like to do is also to use integrate directly check-in without the need to have a quick lock instance locally. And possibility also to have for Visa multiple cloud. I see that there is also a web cloud provider, but I don't know if this is been developed for this purpose. Given that we have like the possibility to contact multiple clouds, I don't know if this is possible or in the future direction that also Visa is going. And this is all from us.
Super. Thank you, Andrea. Good. I will misuse my position. I would like to ask a question, although we are running out of time. All in all, what would you say? How many PMs did you put into getting this so far?
So we started, if I'm not wrong, in before the summer. So I think it was March, if not wrong. And I believe that it was not so much effort from our side because, of course, we have the Openstack cloud was already there, so we didn't have to install Openstack. So it was mainly try to understand how to build the images because, of course, this was not there, and then the deployment of the demo instance with the Docker Compose is quite straightforward. So most of the time we spent like integrating with check-in and to set up the build, so the images. So I cannot tell you now how many VMs, but it was not much. For sure, was not much.
No, I'm getting an impression. I just was the comparison to Soleil. They started super from scratch. So
yeah. But I think that's I think it's less than 1 PM for sure.
Yeah. Okay, that sounds good. Okay, thank you, Andrea and Giuseppe. Good. That concludes the part of Visa deployment. Ludovic, are you there? Can I see you? Okay, perfect.
Yeah.
Perfect. Then please enlighten us on development.
Okay, do you see my presentation?
Yes, I can see your presentation.
Yeah,
yes.
Thank you. So good afternoon, everyone. I'm Ludovic Leroux, and I am manager of IT development team at IRL. So I will talk about the development of Visa at IRL, and more particularly an overview of the different tasks and workflow. Then I will tell you about the TCO and the first assessment of the project. finally, I would ask some question for the future of Visa. Let me start with the different tasks for Visa projects. We have installation. I talk about Visa application, OpenStack infrastructure, and OS images. For this, we need 3 profiles: developer, admin, and admin sys. The overall time depends on the profile, but we estimate that 50% for OS image, 40% for Visa application, and 10% for OpenStack. After we have maintenance for application on the OS images, it is quite easy, but for node issue, it is more difficult because OpenStack it's not always stable at higher end, and it's complex. However, we are considering a version on the hardware upgrade at higher end. For development, I talk about new features. We also have some user supports. For the moment, developers make the user support. And the last task is communication. We need to communicate about new release issues or maintenance period. It's a very important task. If you don't, there may be problems because there are a lot of users. Now I will explain you how developers work. For the software, for the backend, they use IntelliJ for Java, Visual Code Studio for TypeScript. For the frontend, it's WebStorm. And for requests on database, they use DataGrip. After a change on the code, so a bug correction or new features, integration and deployment are automatic on the development environment. Code is pushed on GitHub on the development branch. The unit tests are made by the GitHub action. Then the code is sent on the IRL GitLab for the build, because if we build the container on GitHub, the action is put on the queue. So there can be a long delay before a container is ready to use. It could be important for us to make a build. So we build on IRL GitLab and we push containers on the Docker Hub. In the end, we use Webhook on IRL GitLab to deploy development environment. After that, we have manual test phase, communication, production, deployment, and maintenance support. All the actions are made by the team. At the moment, it's just Stuart. So for us, the principal technical warning for the future development is a database model. It's easy for some light change, but it could affect all the facilities. We know that it's an issue for the agility. But Visa is not only a software. I will talk about TCO. For Visa, you need a decent cloud infrastructure. For ELL, it's 2 controller nodes and 8 compute nodes, 6 for production and 2 for test. It costs also 200 €. We must to upgrade our infrastructure if we want to respond to all requests. For information, in the last week, more than 400 different people were connected at remote desktops. You need other development for integration with your infrastructure system, so like ETL or authorization, for example. You need efforts to create scientific environment. The problematic of collecting, retrieve, compile, and integrate specific scientist software is time consuming and is certainly the most expensive part of visa integration. You need time and skills for maintenance and support. It must be done inside each institute to respect the specificities. You need communication with your users. You must keep track of the versions and communicate with users. It takes a lot of time. Okay, so today we could make a first assessment of the project. For the good thing, I could list the development of the application with a great job of our developers, so Jamie and Stuart, and the user satisfaction, because we had a good support quality. But the support is also a bad thing, because the support is handled by email. So it's not industrialized, and it's a load on visa devs and admin. And we have an issue with sustainability. To make transition with my questions, I can say that the problem for the future development will be the funding. So visa is ready for production, but we have some questions that maybe could be discussed during the roundtables. How to obtain a consensus on future development, how to handle specific development, which process of decision and validation, how to collaborate on developments is very important to avoid faults, and how to communicate between visa IT teams, which channel, email, chat, GitHub, or something like that. So thank you for your attention, and thank you.
Great, thanks, Ludovic. Okay, good. And thanks for bringing up the questions. They will help us. Not that I would like them, but we'll talk about them. Okay, good. They're very important. Good. So before we step into the panel discussion, I would really like to give the audience the possibility to ask urgent questions to the people presenting the deployment, and then later on to Ludovic on the development. So I got one from through Q&A. He was very much impressed by what Soleil did, and he was curious, or he or she, sorry, is anonymous, was curious how many people have been involved in the development and of the infrastructure and the support. So Eric, do you want to answer that question?
Sure. Yes, we were 1.5. So myself and Ryan to set up the infrastructure from scratch. So putting out the hardware together and then deploying Openstack and deploying also other tools around that, Gitlab, Provenance, etc., to set up the support framework around the demonstrator, around the platform for the demonstrator. And so it was a quite of learning curve, high learning curve to assimilate OpenStack, Docker, and other tools required to set up this prototype.
I'm deeply impressed, I must say, Eric. Good. Majid, you wanted to add something? I
just wanted Eric to say also, since when they really started to work on the topic, there must not be any confusion. Eric and Ryan didn't start since the beginning of the project. They joined the project. I remember well, Eric, just last year, during the summer.
Okay, thank you, Majid.
But I would add another thing who Eric didn't say, because the learning curve was very high, but now they are also happy with the infrastructure because they are starting to see the outcomes of its powerful, its powerness, because it's providing them with already ready to use features which will ease their life for the next phase.
Yeah, that's a very interesting remark, Majid. Can I add a question there? Are you planning to use this infrastructure, the OpenStack infrastructure, for more services then? Is that the plan at Soleil?
So
Are
Alain,
you
I will ask you to answer this question, but I think so. Shortly,
Okay, Alain?
Patrick, I think so. Alain?
Yeah, normally the good candidate to answer this question is Alain, as far as I know. I don't know if he's
not in the panel. Kat, can you give him access? Can you give him permission to speak? That should happen now. Hang on a second. I'm pretty sure she did.
Okay,
Yeah.
Patrick, okay, can you hear me?
Yes, I can hear you, Alain. Hi.
Yeah, I think that first remark, as Eric explained, I think the very interesting thing is the Ansible scripts or playbooks that Eric mentioned, as it is the knowledge of how to deploy quickly a new OpenStack infrastructure on other topics. And the answer is that we are currently discussing with control people, with other teams in charge of application, both enterprise management application or control application, to use OpenStack for other subsystems and data analysis.
Mm-hmm.
So this is clearly something interesting in the case of our IT upgrade project, because in fact we are thinking about changing the way we worked for other subsystems such as enterprise management, information system, or control systems. So this
Perfect.
is really something new that opens our mind on new possibilities.
Okay, thanks, Alain. I'm happy to see that you see the advantages for your lab or for your facility. That's great. Thank you. Okay, good. So, is there any other urgent question to one of the authors, the speakers today? Because otherwise we would move on to the panel. I don't see any raised hand or any questions. So, as we make the names of the presenters public, so if you have questions, I'm pretty sure they would be happy to answer your questions directly. Yeah. Okay, good. Jean-François, you want to say something, or is it just in preparation of the panel? Okay, good. I assume that last one. Good. Then, thanks a lot again for everyone presenting up to now. And I would like to introduce the panel and the questions step by step. So we have, again, Fabio from the European Exfil. We have Erwan from ILL. Unfortunately, our colleague from Diamond cannot join us today. He or she apologizes. We have Majid from Soleil. We have Tim Wetzel from DESI. We have Theodor from Eli. And we have Giuseppe from EGI. I don't know if Andrea is there as well. And we have Jean-François, as already mentioned, from ESF. And Nicolas from Alba. I hope I didn't miss anyone. Good. So, we prepared some questions for the panelists, yeah? And as far as I can see, to be fair, to mention, the panelists are already aware of the questions. So it will not come as a surprise to them, yeah? That's important to understand for the audience. Okay, good. So, I will read the questions, and then I would then encourage the panelists to answer the questions if they feel so. Good. So let's begin with the visa deployment and development, what we discussed in the first part of this session. And the first question would be, what are the main challenges and the main obstacles identified in the deployment and in the development of visa at your specific facility? And I can react on raised hands, otherwise I would just step through the panelists and ask them individually. Okay, is someone willing to be the first?
Or I can start if you want.
Yeah, that's nice of you.
I was at IDLL when we started to deploy, and I'm now at TSRF for more or less the same task. And everywhere we have the same difficulties is to change the way scientist works. Visa is very new in its approach. We need time from the scientist, the instrument scientist, the beamline, because these are the person who knows how the users are working and what the software they need, what environment they need, and there are very, very few times available. So I would say the main factor that slows down the deployment of Visa is this one, at least for the facilities I've seen. Reaching the success of ILL with so many users has been, I think it has been really accelerated by the COVID crisis. Without that, we were a bit worried at that time at ILL. Not that we doubt about the importance of Visa of the success it could have, but to get the time and the brain of the scientist. And here we are after the COVID, so remote access remains for sure. Data transfers issues remain, especially in the community where it's not between data centers, but quite often this is on laptops or personal computer of scientists. The problem remains the same, and Visa is still a very good solution, but adoption is quite slow, I would say. That's all for me.
Okay, thank you, Jean-François. So I can see Majid is raising his hand.
Yeah, well, what I should say is mainly in the continuation of what Eric has already said. I would say for us at Soleil, the main big challenge is that at the time we started thinking about this topic, it was not really in the higher priority of interest of our directors. So the first challenge was to try to go towards a given solution, knowing that it is needed from the scientists, but let's say on our own. So happily we had the projects of the experts who was an occasion to go there, but then we faced what Eric said, which is the learning curve. Happily we got some help from ILL and Daisy. Now what I should say is that if I think about a newcomer, I think what should help us, even us and newcomers, is now as we are starting to be, let's say, with even if it's a little critical mass of facilities using or going towards the usage of Visa, is to start to gather our knowledge and to start to formalize in some way our collaboration, to ease our work and to ease the work for the newcomers. Because many think that Eric faced during the learning curve, I'm sure that they were already known from ILL or from Daisy or from many others who were already trying to set up Visa. But as there was no real, let's say, collaboration organization to talk regularly on the technical details of deployment, it was not easy in the beginning.
I mean, that was one of the last sentences of Jean-François as well. Can I ask you something, Majid? Because I am following your process for kind of 1.5 years. You said, okay, we do not have funding for this. Let me talk to our director. And then more and more often you talk to the director, and you got more and more funding. And as Eric said, you now get all those people full time almost for this. So what was the convincing part? So what did you present to your director so that he or she changed his or her mind?
I think what started to convince them is that they started to be more and more, let's say, I don't know in French, we sacred with our choice, because they started to see that it is now becoming a shared solution between many other facilities.
I see. Okay. Oh, that's definitely a good point. Yeah. Let me write this down. Okay. So you're saying that management can even be more easy being convinced by telling them we are not alone, it's not an island, we have our colleagues helping us. And, okay, thanks. Okay, and then next up was Erwan.
Yes, thank you. For ILL, it's quite different. Of course, as Jean-François said, the installation and the COVID helps a lot to start. So our difficulties and our challenge are more on the development and the sustainability. And on that, I have little experience feedback that I want to share. The first one is the image creation. It takes a lot of time. So working with containerization like Aptainer or Singularity is already something to consider at the beginning of any project. The second one is the platform. We today, or as Ludovic said, we have an OpenStack platform that is not really stable, and we need to update that in production. It's quite difficult. It's a real problem for us because we can't upgrade something not stable, so we have to deploy a new one to think how to transfer the VM and so on. So I think it's an issue that we need to consider on the visa development part more than on the platform itself.
Can I ask you something on that one?
Yeah.
Is that do you think it's an intrinsic OpenStack problem, or is it just the lack of manpower you have?
No,
Okay.
I think it's intrinsic to OpenStack, but it's my point of view. I know that ESRF doesn't have any issue with that. I discussed that with Jean-François, so maybe we just start a little too soon and today it's working well. That's maybe a reason, but I know other companies that have issue with all the OpenStack versions. So maybe that's something that we have to consider on the visa development, to be able to have multiple backends. On the development itself, our specific point of view is that we have users, so we want to deliver to users, but we also have other partners, and we want to deliver what the PaNOSC and Expanse wants. So we have this dual needs that we have to fill. It's quite complex, and I think it's something that we have to keep in mind, that when any facility develops something for visa, it has to be on a generic way and to be accepted by to be feeling the quality of the current visa solution. So that's all three main, I think, difficulties that we have today. And just to answer to something, what I've been saying before, the acceptance of users is quite hard to obtain. Of course, Jean-François was here, so he knows better than me, but what I can say for what I see today is once it's in place, everybody starts to spread the information, and in the institute, everyone wants to use it from time to time. It's grow up and so on. So we have to buy every year's new nodes for OpenStack. So the needs is really important now.
Well, but that's just hardware, I would say. I mean, that is
it's
expected.
It's a cost.
It's a cost, but this is what you wanted, isn't it, when you introduce such a system? What I was surprised about is I saw this one slide saying it is not 100%, the sustainability is not clear. This was what your colleague said before. This is very surprising because it seems that ILL kind of is betting on that piece of software. So that the sustainability is not clear surprises me. Maybe you can have a word or two on that.
Yes, actually, the mean to keep Visa going on and grow up is here, of course. The problem is only a budget problem, because we didn't expect to have to buy so many nodes, so many hardware to run it, because we have a lot of usage of it, more than expected. And the second part is the development. Until now, all the developers were financed by the PaNOSC project. So it was clear in the management mind that it was a PaNOSC development. And still, we know that today Visa is ready for production, but we also know that some other things have to be developed, like, for example, the GPU support, if I can say. And for that, we don't have any plan. So that's the concern we have. It's not looking at the end of PaNOSC exactly, but still it's a concern to have.
It's none of my business, but when we started, we picked Visa because we were told that it is used by ILL, and therefore the sustainability, at least of that part, is clear. I'm very surprised to learn that your management thinks it's funded by PaNOSC and it's not so clear how to continue.
I want to clarify what I said, maybe.
Okay.
For example, at ILL, we don't need the GPU.
Okay.
So we don't need to do the development for the GPUs. But if we want it to be integrated in the quality point of view, we have to review at least the code or even write it. And for that part, we don't know how to do it. Of course, for the internal development, it could be done without any issue. But if we say, okay, we can do that in 1 week, we need 2 weeks to do that because we have to put that in a generic way for following other institutes, that's not really, that's blurry. And for the other part is for the hardware that we didn't expect, but it's on our part. So I warn you to expect some usage of your OpenStack.
Okay, so that you need hardware is something I see positive, because it means that people are really, they like what they get, and this results, of course, in more requirements, and then consequently in more hardware. Okay, good. But yeah, thanks for being so honest. So I can see another hand from Giuseppe. But I can't see you, Giuseppe, and I have the suspicion that something wrong with your system. 3, 2, 1. Yeah, I think I'm right. Good. Anyone else wants to comment on this question? Because otherwise we would move on.
I can add something related to the adoption, TLI, and the sustainability aspects that we have considered. It's also part of the activity we did in PaNOSC, and exactly as Majid said, it's important to mention to the management that this is adopted and this is used by different other facilities, and there is a community behind this initiative. At the same time, in our case, we are just starting to operate. So the let's say clear dependency on OpenStack, it's adding a lot of extra stress to the teams, especially since the facilities have evolved independently. So it's crucial at this stage to have a critical number of laser scientists collaborating with us and defining clear the requirements. The users have expressed interest. So far, we have discussed with a number of users who conducted experiments. So there is a clear interest in using Visa or a tool similar to Visa. The requirement is there. How we'll be able to support it in the future depends on the computing strategy of Illyric. So if we adopt an OpenStack instance or consolidate a central computing infrastructure, or how exactly this is going to look, it depends on let's say a strategic decision. Ideally,
so
it would be good.
Yeah, it seems to depend a little bit on the infrastructure decisions as well. The adoption.
Yes.
Okay.
Yeah.
But it is influencing it crosswise. So if enough users would request Visa, you would consider OpenStack.
Exactly.
Okay.
So it's a cross dependency. It just depends on the number of users asking for it, number of scientists committing time and allocating time to support and to provide input. so that we can make a solid and strong use case to the management.
What is the path you would suggest users should go in order to influence management in an optimized way? It's Twitter.
The only thing that I comes to my mind at this stage, because it's one of the most important arguments we have, is pay attention to the data management plans and do not avoid questions related to computing and remote data access. Because most of our users are somehow not really happy in going through the data management plan and providing this kind of details. But at the same time, when we enter into the discussions that are, let's say, experiment setup, because we have a phase after the proposal is adopted, there is an experiment, let's say, preparation stage, where it's not a structured DMP-like discussion. It's just we go through a list of 60 questions which are in an Excel. That's the moment when the users are not fighting back. They're happy to contribute because they see the clear connection with their experiment. But facing the DMP from the other point of view, it's just a checkbox, whatever. We are not really into this and so on. They don't connect it to the real scope. So paying attention to this kind of requirements and just consider that these are support questions. That would be ideal. So it's about training a bit the users to understand that we aim at providing better services.
Mm-hmm. It's complicated, I understand that.
Yeah.
Okay, good. So there are many questions from the audience, unfortunately, because I wanted to move on. So let me see if you can answer some of them. So there's Uwe is listening, Uwe Conrad is listening, and he has a question that as Daisy is setting up and using Ansible, would that help for the continuous maintenance process? Is there someone who can answer that question?
Maybe. I am not sure where the Ansible part comes from. Maybe that was a misunderstanding. So we're using Flux CD with Helm, which is not Ansible to set it up. But yes, having a system like that in place, together with our self-maintained Helm charts, which I tried to briefly show earlier, that helps a lot in the continuous maintenance, because we can easily copy, in quotes, deployments, test them before we update the production instance and see what effects we have to experience before we go live with such changes, be it in the ETL process, be it after a Visa upgrade on the ILL side on GitHub. So that's very feasible, yes. And to answer your next question, Uwe, directly, because I'm seeing it here, it was not our presentation that mentioned Ansible.
Yeah, it was the presentation of Eric.
Yep. Okay, so Uwe, okay, thanks for your question. And there is a remark from Alain. So regarding communication with institutes management in the past on the Tango project in this particular case, what helped was first set up an MOU with probably the community, and secondly, setting up a Tango foundation, which is of course a big step, to also introduce money to sustain the effort. That I can understand is not so easy. But that would, of course, be perfect, yeah. And I think ILL would really appreciate that. So the memorandum of understanding is probably easier, but it is not so binding. Yeah, it is already good that people talk and commit to something, at least virtually. Okay, good. So, but we're coming to this later in the sequence of those questions. So I would rather like to move on because we are really late. So let me check the follow-up questions. I think the next question was already answered a little bit. It is how do we think? What do you think would be needed to overcome them? them is the challenges and obstacles identified during the development and deployment of Visa. Yeah? And I think we already learned some possibilities, especially convincing management. This always helps. And then I would like to move on with what are the lessons learned. I think this is a very open question that we could talk about this for hours.
Yeah.
Is there someone who can say, okay, there's something I definitely learned? Is someone brave enough to say that? Say something. So nobody learned something. I warn you, if you're not saying something, Majid will.
No, there's not something I learned. Something which confirmed an already known conviction, which is that as soon as we collaborate, things and obstacles and difficulties are overcome.
Yeah, that's great that you're saying that, because this is essentially what the two labs of us learned. I mean, it was super to have you at Daisy for a while, and we learned a lot, and I hope you did as well.
Yeah, definitely.
Good. So, Fabio, you raised your hand next. So you were brave enough.
A bit more from the personal perspective, because I got into leading this work package for PaNOSC right in the middle of the project or later, a bit more than a year ago, without really the technical background. So there, of course, we are really, really glad to have the collaboration with Daisy and Tim and Michael and others, the competent, right? It was surely an advantage that they had the OpenStack cluster already, as was mentioned. But what I learned is, of course, this borderline between the purely technical things and strategical decisions, and how the strategical decisions and the technical consequences may interact. To give an example is, as may have become clear from my demo, is European Expert decided to start Visa first as a service for open data and training data, even step by step, right? But this influences, of course, for instance, the ETL process, like how does the data model map to the Visa database, how it was foreseen by ILL, right? That would on two ends be interesting. Whether I mean, I think also ILL now opens up with a guest account, etc. This model, but how the facilities have to adapt and things like that. And yeah, it is a bit convincing or negotiating with the upper levels, the decision makers, right? Because it's open data was also a starting point, because I think there was a thought that the established users, it's hard to compete with the established services if they're used to, right? But if we can attract maybe first the new users that need an easy platform for training, and this is the process is in front of us, right? To get more and more attention, and but I think this could be a seed of these new users who, if they will find this useful, right?
Yeah, this is a little bit in line with ILL. So you start small, you convince the users. Users are stepping forward. They like it. I mean, if they like it, yeah. So you have to be good, and that will at some point reach management. So. It's yeah. Okay, so there is Nicholas who wants to say something.
For lesson learned, I just wanted to point out that when I arrived at Alba a bit more than a year ago, people were working on this similar project called Calypso, which we ended up being the only one working in that. So for us, it was crucial to be inside this network of facilities, I mean, Expanse and PaNOSC, to take the decision to switch to Visa, because we had the reassurance to know that we were not alone and we could count on each other for this development. So it's really shaping what we do. That's what I learned. And it's important that we continue doing that in the future.
Yes. The first, I agree. And the second, we have to find out how.
Yeah.
Okay, so that's probably not the easiest part. Okay, anyone else learn something? No, disappointing. Okay, then let's move on. So now we come to this really difficult point, which is the sustainability. Yeah. There's one thing which improves the sustainability, having more customers. And in the direction of having more customers, it might be necessary to increase the set of functionalities provided by a tool, in this particular case, Visa. So the exact question is, have you identified any missing functionalities that could be added, modified, or readjusted, and could improve your use of Visa, and with that, the probability of sustainable support? Tim, you were the first.
Yes, I mean, this is very special to our deployment strategy, but thinking about the current energy situation in Europe especially, I think it might be sustainable if we had some module in Visa that would allow us to not only spawn OpenStack VMs, but also spawn Kubernetes containers instead of these OpenStack VMs, because to my mind, they are energy-wise a bit more efficient than a whole VM, having a container that is scaled down by resource-wise when it's not used, scaled up when it's used. Might be good to have that, but as I said, it's quite special for our use case, because as I saw, most instances of Visa are purely using OpenStack, right? It's just an idea.
Okay, good. The counter argument was always that if you take the energy consumption of a synchrotron, okay, but,
yeah,
but you're right. I mean, I would sign this Kubernetes thing. Are there any remarks or thoughts on support of Kubernetes, energy-wise or not?
If I may, I think it's, for us, at least for ILL, it's not something we are looking to. However, I personally understand that the need can exist because actually OpenStack is answering all the needs. It's working very well when it's stable. On the table, it's working very well. So we didn't look on that, and we lose the capacity to, for example, launch Windows machine and so on. So we focused only on that. So just a remark that we don't look onto Kubernetes as a backend for now.
I mean, supporting Kubernetes would not support OpenStack.
Yeah, exactly.
So you're not losing the ability to start.
It means just have to understand that it means that if we, for example, ILL, we want a new feature on something on backend or something.
Yeah.
We have to have a whole Kubernetes infrastructure to test on it before releasing, and that has some difficulties in terms of hardware, of course, but also in terms of time consuming on testing and so on.
Yeah, I think we are back to the point that as soon as the community wants something which is not in particular in the interest of ILL, the community has to provide human resources plus testing hardware resources. And we will get stuck with this, I think, after each and single question, I would suspect. Okay, thanks Tim and everyone. Okay, anyone else on that topic?
Patrick, can you hear me?
Yes, Giuseppe.
Oh,
yeah.
Okay, it works.
Yeah, but
okay.
I can't see you. I can't see you.
Yeah, I opened my webcam, but I don't know why something is wrong with my system.
Okay. Good.
So about this point, I think it's not related to the technical functionality, but what I think should be improved in the future is the level of support offered to the end user, because as was mentioned before, this is not very structured at the moment. So it's just Stewart and Jamie in the past that basically provide support by email. So something more structured, I think, should be considered if we want to open the services to a wider audience.
Yes, exactly. And here we are again. Who is going to do that?
That's another good point.
EGI could make an offer.
Yeah, of course, we can open a dedicated service support unit in our system. Why not?
Yes.
It's something that we can do.
which is only the first step. Yeah.
Yes.
No, thanks, Giuseppe. That's a very, very good point. Of course, yeah. It is the one of the bits we need in order to have this community-like endeavor. So, Majid, you.
Yeah, I wanted to say that there are another functionality missing. I know that at some point Jamie has started to do small POC to try to introduce a Slurm infrastructure directly as a way of instantiating images. Don't know if you remember, because what was interesting is that when we started the project, there were no API to talk directly to a Slurm infrastructure. And happily, during the project, it came, and Jamie was interested, but unfortunately, the COVID crisis came also, and so we have had other priorities. And I think it's a very good, very important functionality, because it will be sure that not all the facilities will be able to install an OpenStack infrastructure. It's not possible. Some will just not be able, maybe money, maybe resources, maybe. And if we want to enlarge the community, this development will have to be done. I'm not saying that, well, the question is there. Now, when we come later to the way we can collaborate, we can see how it could be done. But for the project, I'm sure that as soon as we get this future, it will open the door for other facilities, labs, and
yeah, I mean, I could answer as if I would be the PI of an open source project, I would really welcome your comment on this, and I would say it's a very good idea, this feature request, and then please go ahead and build it in.
So we'll come later.
We'll come to this.
We'll come later. I will anticipate. At Soleil,
okay.
This is what we are foreseeing, but I want to say it when we come to the topic of collaboration.
Okay, good. On that particular question, any further remarks? Do I see a hand? No, I don't.
Jean-François.
Oh, Jean-François. No,
I'm puzzling. I try to understand what you mean, Majid. You want to spawn on a Slurm node, a VM or a container?
A container.
That will run for days and days and days and block your Slurm resources. That's
I will not be able at that point to talk about the technical details. What I'm sure is that one of the obstacles is that it was not possible for Visa to interact with a Slurm infrastructure because there was no REST API to do it. You see what I mean? For example, now, today people can
yes, I know about the Slurm API, which happened, which appeared some time ago in the recent release, but I still don't see the. When we do Visa on VM, when you look to it from an energy point of view, on your OpenStack, you have an overcommit or overbooking factor of 17, something like that by default, which means that when the VM is not used, consume nothing and let the room for the others. And this was one of the ideas from the beginning from Visa to make something very cost effective. When you launch a job on Slurm, by default, you got the number of cores you have requested, the
Mhm.
RAM, and no one else can use it.
Okay.
This is a scheduler. So this is why I really don't see the.
Maybe we can keep this question for
Yeah.
later technical discussion.
Exactly.
I
Yeah.
really can't answer your question, Jean-François, now.
Okay, good. Thanks, guys. Let's move on if there's no one else who wants to contribute to that particular question, because the next question is related, of course. If so, which means if you have identified any missing functionality, which we did, will you be willing to continue working on the resolution of those issues and improvements after the... Yep. Did I miss a
Because
question?
I've seen that John Halliwell added a question. I don't know if it's...
Where is it? Oh, sorry. Yeah,
just now.
Yeah. Well, that's a long question. John.
It's a John Halliwell question.
Am I supposed to read this now? Or does John wants to join us? Kat, can you give him access?
Yeah.
I certainly can.
Thank you. Thank you.
Can you hear me?
Yes, we do.
Yeah. Hi, everyone. Yes, it was just, I thought there was an interesting parallel. Really, the two questions are connected. Getting your directors on board on the one hand and users and beamline scientists, and of course the sustainability, because if you got them on board, then the resources will continue to come. I saw a parallel with the IUCR Committee on Data consultations with the different IUCR commissions about raw data archiving and importance. So where basically a field is relatively not that mature, then there's a strong interest, because of course the scientist's reputation rests on the result being fully understandable by the readers and users of publication and associated data. And so they absolutely desperately need the kind of capabilities, wonderful capabilities that I can see that your visa is offering. Then where a technique or science area is relatively very mature, let's say chemical crystallography, then there's been relatively much less interest in raw data, because the procedures seem to be really very smooth and streamlined. But in their detailed workshops, they concluded that where samples are challenging, the diffraction patterns, the spots might be very streaked and so on, then they're very keen on having raw data archiving and clear recording of workflows. So I think the reproducibility overall is the key thing, because in the threat of irreproducibility is something that all of us as scientists, with every publication we make, there is a growing worry in the whole of science and politicians and the taxpayers about irreproducibility. And so what you're developing, I think, is a terrific thing, because it's giving that clarity of workflow, it's connecting to the raw data, but the take-up, will be this around the documenting reproducibility. Of course, you've got an additional angle, which is where and I think Patrick or Erwin maybe referred to it. If it makes the life of the user and the beamline scientist easier, then that's an additional win. But I think this overarching landscape that we're in of research integrity questions and irreproducibility worries, is a big thing. And I think any director is in defending their facility, they're going to get on board with that. Anyway, that's a quick summary of the IUCR Commission's responses. Powder diffraction is still cogitating. That there's some interesting sort of papers and so on considering raw data and powder diffraction. Macromolecular crystallographers are very, very much on board, because they see that various areas are, are not that mature yet, and the full documentation, raw, process derived, and the workflow is very important. That's my attempt to do a synopsis. Sorry, guys.
No, I think that was a very valuable input. However, I'm still struggling to find how to convince our management that fighting irreproducibility is necessarily bound to visa. You see, they will always sign what you said, but then do we need visa? You see, are there other ways to do that? Kind of beating up scientists who are not open data or something. This is something we have to figure out.
I take that point. I mean, Patrick, that if you think of CTB4, then they're pursuing a CTB4 cloud. So it's, you know, directly connected to raw data. It's documenting workflow. So in a sense, there in macromolecular crystallography, you've got one example of a direct competitor. What the imaging people are doing, I think, is much less well organized. There isn't a collaborative computing project, to my knowledge, in imaging. And so you in that case, you would not have a competitor.
Yeah. Yeah. Okay, good. I think that is something really important to keep in mind. Finding the right arguments towards management, and this is definitely one. Okay, thanks, John.
Thank you.
As Nicolas wants to say something.
No, just to say that in our case, Visa or a solution to process on site is mandatory because we have a tomography beamline coming and a serial crystallography beamline coming. So sometimes the data set reach hundreds of terabytes, and you just want to avoid the burden of transferring all that. So that's the main incentive rather than having workflows and things like this. It's really to avoid the data transfer, which are not amenable for users.
Well, so if you are saying that Visa has a particular value for you because there's something coming up which highly depends on a functionality of Visa, yeah, then how much value is that for your management? So if they're sure they need Visa, they cannot expect this to get this for free.
I mean, this is the main selling arguments that we use every time we explain what Visa will be about. But of course, you have also other benefits from it that you mentioned.
No, I mean you have a selling point, and the management is buying it, yeah. And then, but management knows while doing it, while agreeing that expense will be over at some point and PaNOSC. So how do they expect to benefit from the advantages of a product of which they know the main funding agency is going away? They must have put some money aside, saying, okay, look, if there is no project anymore, we cannot afford this project or this product to go away. So let me put some money aside to support them, and this is exactly what we need. Yeah, this little bit of money from everyone.
I think they expect that while on rail it will be maintainable.
Okay.
You have some inertia to.
Okay. Good, but they rely on us to find the solution here. Okay, Evan, you wanted to comment.
Yes, another idea in this, the idea about how to sell it to the management. Again, we are not in the same position because it's mandatory today for us. But yesterday I saw my director who said that we had to make some efforts on CO2 usage and on global transport and making people come and goes, and Visa was one main part of it. So it was an argument to say, okay, with Visa we have decreased the amount of people coming because they come to do the experiment, but after that they can work from home and from their own countries and so on. It's a little one, but still I think it's a greenwashing one, so maybe interesting.
Okay, yeah, that's true. Okay, thank you. Any more comments on that bit? Then I have to find my questions again. Good. So now that the next question on my list, I would really like to skip that because it's becoming really technical, and I think we only have half an hour to go. Therefore, I would like to start the discussion on future collaboration. Yeah, there's this first sentence in my question which I already repeated various times, that PaNOSC and Expense are coming to an end. And there is the need to anticipate the end of this project, and with that the financial and networking resources offered by the project has to be replaced somehow. Yeah. So, and now is the question which we try to kind of to answer for the last 1.5 hours already. How do you foresee the future collaboration on Visa? Yeah. I think was it Jean-François who stressed some requirements on how to continue. I think it was you, Jean-François. No, I think it was Erwan saying on communication and on how finding a collaboration kind of agreement framework and so forth and so forth. So if you would like to kind of repeat this as a starting point for this question, I think, Erwan, that was you on your last slide, isn't it?
It was Ludovic, I think, but again, I think Jean-François and me are on the same page.
Okay.
So if you want to take this, Jean-François.
Yes, but you can. Yes. For us, for ESF, this is a starting service, but we really believe that it will become critical quite soon. And the main argument for the directors is the publication. What's the point of having so many experiments and having users in difficulties to process the data to get to the point where they can publish? So there is not much question on that side. Now the question is, how do we want to collaborate? Who wants to collaborate?
Yeah.
Tango, it was mentioned by Alain Buteau from Soleil, is a good example of a collaboration. We have few, but some good examples. Probably the first point is to identify who is really willing to start a collaboration. And secondly, something a bit naive, but usually you have a MOU. This is the case, and this is the case of Tango. You have an MOU and you have a sort of management committee, steering committee for the project, and you have a technical committee. So some people being able to evaluate the technical feasibility, the cost, things like that. We have some examples. I think the main question is who is really willing at the end of this project to enter into more long-term collaboration.
Yeah, and we don't need customers for Visa. We need contributors. Yeah.
Yes.
I mean, if I would now count the people who depend on Visa, or as Jean-François phrased it, for whom it will become critical, yeah, then I would see a lot of raised hands. But then, if I would ask, then who would contribute by, let's say, 1 PM per year? I don't know if someone would commit to that.
But this is not necessarily the model of contributing with PMs. We can find.
I mean, just
yes.
You can always transfer or map it to a PM, because there's always some contribution which takes time, which is then of course a PM or something. Yeah. Or let me phrase it differently. Who would contribute significantly, really spending time or money? I mean, that's fine too. How much raised hand would I see then? Yeah, I don't know. Yeah, Majid?
Yeah, well, Jean-François, you mentioned the Tango collaboration, and Alain could comment on it. I had the chance that I was from the beginning the Tango project, and it started really small. I know that now if we go at that time to our direction and say to them, we will have to commit 1 PM to the project, or they will say no. But when we started Tango, we made up an MOU, which have been to be agreed by the direction. And in the MOU, we was stating that we will contribute, let's say, in a best effort manner. For our direction, not to be afraid. but just saying that now there is something which is formal, official, and all these facilities are saying that they will collaborate and contribute to their best. One other thing we came with is that it helped us at least to organize the way we are contributing. As everyone said, of course, sometimes there are something specific, and if you want it to be generic, it will be at some cost for IL, and IL cannot do all this work all the time. The collaboration can at least help us at each time one facility is interested in a new feature. We are agreeing between all of us at least to define the way this facility will do it, to be sure that it is generic and it is beneficial also for the others.
Yeah, I see what you mean. I mean, exactly.
And when we reached this first step and we started to come out with things, many features, it was easy for us to come to our directors, because during this time, the service was installed and critical for all our facilities. And after this, we went to our director and told them, now we must commit ourselves in a consortium and to pay money each year. And this is what we are all doing in the consortium of Tongo.
Yes.
And the directors are paid.
I'm well aware of this blackmailing process. Yes, you make him dependent on you, and then you ask for money. No, I'm just kidding. No, sorry. I'm just kidding. I'm just kidding. So I understand that it is very important to start with the process, and I think this is what everyone will kind of commit to as well. So there must be a process, and it must be clearly defined, and we could start with best practices and with an MOU.
Yeah.
Okay, that is a take from you, and then everyone wants to say something about this.
Yeah, yes, just to go on with Jean-François, what Jean-François is saying. As you say, we are forced to use Visa at ILL, as we said before, and we will continue. We are willing to continue with everybody, of course, and to take a huge part on it. So I think it's a good signal that we want to send, at least I try. However, we will have some difficulties, and for example, it's that we have, in your DNA, is that we want to give services to ILL, and this is really all users who are focused on. So to develop something for outside, it's quite difficult for us to change our mind and so on. That's why we didn't start the Jamie replacement right now. We want to have this discussion to know what profile we want to fill in, to find something to replace not Jamie but this position, and it's not very clear for us now. So we need this to know, as you say, Patrick, to know who will be interested to work with us, and what the form it will be, and of course we'll try all our best to fill in that. But we just want you to know that every specific we have some difficulties to understand the specific, because we are focused on all users and all needs right now. We have to evolve on that.
Exactly, and there's some difficulty as well. So whenever we contribute, what we want is that it is still a product for ILL, which is important for ILL. It doesn't make sense to fork it, do what we like, and then ILL has a second clone or something. This is absolutely not what we want. That would be stupid.
Exactly. I should have started with that, and I say that before with Jean-François also, that the first thing we want to avoid is a fork from anyone, from ILL or for anybody else. And that's what Majid say. If we work together, we'll go far further.
And then it has to, everything we contribute. Look, what I see as a problem is, sorry for stepping in now, is that for those sites for which Visa is not critical yet, the contribution could be of, let me say, not optimal quality. It could be that they just add things to try a feature or something. But that, of course, would be not acceptable by ILL, because for them it is critical. So we have these two approaches here. So we have to come up with a process for versioning, where we have those test versions and production versions, enterprise versions, and then we are getting into something where we need a software maintainer who ILA probably doesn't want to pay for. So it's getting tricky at that point.
Yes, but isn't the first step to obtain users? I'm just thinking out loud. Maybe once you will have users, you will not think this way. We'll just say, okay, it's a critical production solution. I don't know if ESRF is already on that, but I think they're already close to be on that. And they will, I hope, join the point of view of ILL on that service is critical, and they can test things they have to run in production.
Yeah. Good. So to be fair, Alain wants to say something for quite a while now. Can we give him access so that I don't have to read 3 comments from him? Kat? Can we let him speak? Okay. So Alain, speak up.
Okay, do you hear me?
I can hear you, yes.
Okay, so nothing really new regarding what Majid said, but I think in our case, we cannot justify today that Visa is critical, because in fact, it's just prototype, and we will present in the next weeks a plan to set up to have a production ready Visa to our direction. But what also helped in the past is MOU is something quite light, which once the management, at least the management understands that it is something that impacts the organization. It's not only some gadget from the IT guys. It set up something official. They are used to this MOU, at least at Soleil, because I have MOU with CERN, with ILL, with ESRF, whatever, for machine physics or whatever, for instruments. This software is now as important as RF cavities, for example. So setting up an MOU, it puts something official for top management. And then what happened in the Tango Foundation is that, as Majid said, after months or years, everyone is aware that this is mission critical software. And we invest so many time and so many efforts at having the control system working with Tango, that paying, I think it's about 10,000 euros per year just to have a common effort sustained. It's not a lot of money, in fact. But I also agree, Patrick, that in fact the added value is not only 10,000 euros, which is it's more the collaboration between people, and that's in the case of Tango, the risk of forking, in fact, is quite zero, because it's we had some forks on some subcomponents, for example, for Java GUI components, but the core system stayed. We stayed. Everyone stayed in the same collaboration for the core system, because it's impossible for one institute to have to go alone in this direction. So I would not be so afraid regarding fork. But of course we have to sustain the effort, and we had meetings and meetings and discussion of what can be the contribution of various parties, because I don't know, for example, Erwan, he has resources in JavaScript or really development skills, but in my group I do not have this skills, so I cannot contribute on this part. But of course, Eric is a very good sysadmin, so he can help for call Ansible stuff, for example, or for automation of Openstack setup. Okay, the contribution of the parties can be of various kinds. People, trainees, or money. But that money has also to exist. And in the case of Tango, the money allows to pay for some the maintenance of some components. Because in fact, neither ESRF nor Soleil can maintain, for example, the C++ code library.
Yeah. So I have another example where the open source was, or this approach was successful, although not in the sense one would think, is that we started with a storage product here at DAISY, and we were thinking there would be contributions by others. It was open source, everyone could contribute. This didn't happen, but what happened is, at some point, another side said, it's so important for us, we will commit now. Yeah, we will become a partner of you, and then we commit to so many PMs or so many FTEs. And then the third joined and the fourth joined. Yeah, the idea that arbitrary people contribute, we forgot about this. This didn't happen. Yeah, but there were committed sites, and they were committing by so many PMs or FTEs, if you like. Yeah. Okay, so it works after a while, but it is, as you all said, people vote with their feet. You first have to convince the customers that it is good. They have to convince the management we need this tool. And then the management has to convince, okay, now we might contribute. And from my management, as we were the headquarters, they took a lot load initially by themselves because of prestige. Yeah. So we didn't want to leave it to CERN to be the data management of the world. So we fighted it a little bit, yeah, and that was what DAISY management convinced. Our name will then be mentioned more often, yeah. So it's a little bit this kind of thinking. Okay, so it seems to be more complicated than we started with, but I think we have identified a lot of things we have to take into account. It's not only the development, yeah. So we have to have someone who is keeping track of all the changes and so forth. Yeah? It's not just putting things in, but sorting them, making sure they have a certain quality and all this. Then, as Giuseppe said, you need proper user support. Yeah, you cannot. This amount of people we have in this community, you cannot just leave them to email exchange or something. Yeah, and that is the way into the users, and then management comes in. Yeah, and we have to start small. You're right. Yeah, it has to be an MOU. It has to be best practices only, yeah, no enforcement of something. And most importantly, we have to establish a process on how to contribute, yeah, not just random addition of codes and something, yeah. You know, the framework around this is becoming, it's not easy, yeah. And then we have a remark again from Mr. Anonymous attendee. In the case of Tango, what helps was the close human collaboration during many years from the core partners. Yeah, I think that is absolutely correct. Yeah, it's much easier if you know each other and you trust each other. That's true. Yeah, absolutely. Right. Good. So we are approaching the end of the session. If I'm not completely wrong here, it says 15:50. Right. Yeah. So. Is there anyone who wants to add something to my kind of pre-conclusion remarks? No. Jean-François, you were the first, be the last.
Yes, something that would be interesting is to know who in the current state is willing to participate in a MOU.
That was, I would say,
quite
us.
Sure.
And Nicholas and Erwan.
Erwan, I know. But...
Yeah, that is good to know, Erwan.
So I put Daisy, Soleil, Erwan, so Hillel.
And European Expert, yeah.
Expert. And I heard Alba?
Yes.
Yep. Yes, Alba.
Okay. And
good.
And probably ESS.
ESS.
Brian Lingwood Jensen said ESS. Likely, very likely.
Oh, here we go. Exactly.
Okay.
Good.
Well, closing remarks. Thanks, Soleil, for organizing Soleil and all the people around for organizing this workshop. It's really good to see. That's really good to see what has been done by the different user facilities, and we have not so many workshops, Expand and PaNOSC. And I know the people of PaNOSC, not so much all the development that have been done in Soleil. That's really good. See that people are progressing.
Okay, thanks, Jean-François. And let me thank everyone who contributed to making this a successful workshop, our colleagues from Soleil, and thanking especially Kat for keeping an eye on everything, and of course to all the contributors. So I think I didn't forget anyone, Jean-François. Help me.
I think it's okay now.
It's okay. Good. Perfetto. Okay. Thanks a lot, and have a nice Friday evening and a good weekend.
Thank you.
Okay. Thanks. Bye-bye.
Bye.
Bye.